Morning, everyone. So, I hope all you people are doing great. Yeah. Okay. So, we'll start our session. So, yesterday I gave this question as a homework for you. I hope you have solved this question. The pile of 0.5 meters and length 10 meters is embedded in a deposit of clay. The undrained strength parameters of clay are cohesion and angle of internal friction is 5, which means the soil is clay soil mass and the skin friction capacity they have given for an adhesion factor of 0.6 is. So I asked you to solve this question. I hope you have solved this question. Yes, I have been look over. I have been looked into the problem regarding to this download of PDF. Yes, the option was not appearing over there. I have already intimated to the technical team. Probably by today it will be resolved. So don't worry about that. The PDFs, yesterday PDF. So there is no option appearing for the download. So I have also checked that and I let the technical team know that so that they can resolve. I think by today they can resolve that. So don't worry about that. Yeah, okay, fine. Now, let's go to the next topic. The next topic is pile group. Pile group. So the next topic is going to be pile group. See, so far we have been discussed in the yesterday's class how to determine the ultimate load carrying capacity for a clay soil mass. Means under a single pile, there is a single pile under clay and under sands. I have been discussed about how to determine the ultimate load carrying capacity of pile and how to determine the ultimate bearing capacity in the case of sands and how to determine the safe load and what is the dynamic formula we have been discussed. Now, but in general, are you going to prefer a single pile or a group of piles? Generally, we prefer the pile as a group. Now, wherever you see, if you observe, whatever this is nothing but a pile group or not, you see, you can observe over here, a group of piles are going to be present or located over here. So pile number 1, 2, 3, 4, 5. Likewise, you can observe there is a lot of group of piles 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So likewise, in a given, generally a structure is going to be constructed based on the group of a piles. Earlier we discussed about an individual pile and this individual pile is the one part of the group of piles or not. Okay. And now between one pile to other pile, there is some spacing. You please observe. Between one pile to other pile, there is a spacing. And this spacing defines the behavior of a pile under the action of load. Whatever the spacing is there or not, see between from one pile to other pile, so there must be some center to center spacing would be there. So this is known as a center to center spacing. And this center to center spacing defines the entire nature of a pile group. So now let's see what happens if a pile are going to be installed in a group. So this is a pile group and this is a pile group. You see here, these are all going to be the pile groups only. which means generally the piles are going to be installed in groups, not in individual piles. Individual means only one pile, but group piles means this number of piles are going to be more. Okay, fine. Pile group. Generally, pile star installed in a group and covered with pile cap. This is also known as a raft. Covered with a pile cap, or is also known as a raft. Okay, and minimum number of piles required to form group is, see, if you want to form a group, the minimum number of piles you require is going to be 3 piles. The minimum number of piles you require is going to be 3 piles. With 2 piles, you cannot form a group. So now let's see how this is going to be acted over here. If you observe, let's take an individual pile. Let's take an individual pile. Have a look. If I take an individual pile, if you observe, there is an individual pile. So in the case of the individual pile, first let me draw those things. Yes. There is a single pile or individual pile. And similarly, you take a pile group. You take a pile group. Yes. So now this is a pile group, and this pile group is going to be provided with a cap. Yes. So whatever here I represented, this is a single or individual pile, and this is a group pile. Say I am taking you the sectional view. I am taking you the sectional view. So there is a one pile group over here, which is going to be having a 3 by 3. Now you see, so when you provide this a group pile, and now I have provided you this one as a with closure spacing between piles. Okay. Now if you observe, in this case, if I draw the pressure bulb or if I draw the isobars, you know, this is nothing but one isobar. What is this? This is an isobar, right? Likewise, you can see the pressure bulbs, means you can see the isobars are not. So if I connect all those isobars, now you know the meaning of the pressure bulb. So this is going to be the pressure bulb. Whatever, this is nothing but the pressure bulb. See, in the case of the single pile, this is going to be the pressure bulb. Whereas when you go for the group piles, now keep that in your mind. When you go for the group piles, what is going to be happen? If this is a one pile, this is going to be the pressure bulb for that pile, and this is going to be the pressure bulb for the other pile. And again, this is going to be the pressure bulb for the another pile. Now, in the case of the group piles, you observe over here, in the case of the group piles, what may happen over here is, if you look, this portion, due to overlapping of the stresses and due to disturbances, see how many piles are there? 3 piles are there. Let's take 3 piles are there, and in its plan view, means this is a section view. In the plan view, there is a lot of piles are there. Forget about the piles. Look, if I say this is going to be the overlap over here, and is a group pile with a closure spacing between the piles. Yes or no? And now, whatever the pressure bulb for the whole overall group, for the whole group, this is going to be the pressure bulb. Yeah. So this is the pressure bulb for the whole group. So now, if you observe, this is the pressure bulb for the whole group. Because if you see, in this case, as you see, the spacing between the piles is going to be very less. Then there is a stress overlap. Whatever, this is nothing but stress overlap. And similarly, I'll go with the different See, I am providing the same group with a wider spacing. This time I am providing with a wider spacing, group file with wider spacing. What is going to be happen in the case of the group file with a wider spacing, sir? If you see in this case, there is a pressure bulb and there is a pressure bulb and there is also going to be the pressure bulb. See, in the case of the closer spacing, there is a stress overlap. And in the case of the wider spacing, there is no stress overlap. When there is no stress overlap, my dear students, see, if there is a closer overlap, then the entire pile is going to be behaves like a block. Then the entire pile is going to be behaves like a block. And when the spacing between the piles are going to be more, when the spacing between the piles are going to be more, and each pile is going to be acts as an individual pile. So what I want to say here is, in group piles, the ultimate or the total load carrying capacity of n number of piles is not same as n times of capacity of single piles, which means may not same as in group piles, the total load carrying capacity of the n number of piles may not same as n times of the capacity of the single piles. See, I'll be using this will as capital M. What is the meaning of this one, sir? You see, look, whatever the group carrying capacity, QG, what is mean by QG? So QG may or may not be equals to, where QG load carrying capacity of group, load carrying capacity of group, and QI load carrying capacity of single pile. So now the meaning of this one is, if you observe in group piles, the total carrying capacity of n piles, the total load carrying capacity of n piles, QG, may not be same as the n times of the capacity of the single pile. See, for example, if I say, listen, what is the meaning of this? Listen. For example, I say there is a one pile. Now let's take this is a pile, whatever this is a pile. So this pile is going to be take a maximum load of 1000 kilonewtons. Let's say this is going to be behaves like 1000 kilonewtons. Now you are going to provide these type of piles in a group. You are going to provide these type of piles in a group. Let's say there is a pile group of 3 by 3. What is meant by 3 by 3? 3 piles in a row, 3 piles in a column. So total number of piles are 9 piles. This pile is going to be individually, it can take how much load? 1000 kilonewtons. Individually, it can take 1000 kilonewtons. But now when you keep this pile in a group, when you keep this pile in a group, do you think, sir, 9 piles are there now? One pile will take 1000, then 9 piles will be 9 into 1000. No, it's not going to be same always. That's the meaning of this one. In group piles, the total load carrying capacity of n piles, 9 piles is not same as n times of capacity of single pile. 9 piles means n times. 9 piles, 9 into single pile, 1000. So just because this single pile will take 1000, if you keep this pile in a group, it may or may not take the equivalent value. Why, sir? Why? Because due to the stress overlapping. Now, the reason is due to stress overlapping and disturbances caused may due to stress overlapping and disturbances caused due to less spacing between the piles made the group capacity is less than the n times of individual capacity. So stress overlapping and disturbances caused due to lesser spacing between the piles made the group load carrying capacity is less than the n times of the single piles. See, generally one single pile will take 1000. 9 piles are there, 9000. But when you keep these piles with a lesser spacing between the piles due to stress overlapping, the value is going to be less than n into qi. And due to densification, if proper spacing is provided, due to densification of soil between piles and adjacent to pile, then the group carrying capacity can be more than or equals to n into I, where n is number of piles, where n is number of piles. Where n is a number of piles. So mostly the spacing is going to be the main parameter. If you observe over here, see, this is going to be acting as an individual. If you observe, whatever the soil mass are present in between the spacing, whatever the soil mass is going to be there, whatever the soil mass, let me take this figure again. Yes. Yes. So if you take this one, whatever the soil mass present here, see in between this is a soil, right? And this is also soil. So whatever the load, that is going to be the group load. The total load is going to be the group load, and whatever the load in each pile, this is an individual pile. That individual pile is going to be Qi, and this is soil and this is soil. So due to these values, okay. Due to these loads, the soil mass present between the piles and adjacent to soil mass, so it is going to be due to densification, the value is going to be more. So, my dear students, no matter how many number of piles are there over here, so generally the group capacity means the group load carrying capacity can be less than the n times of the single pile, or more than the n times of the single pile, or equals to the n times of the single pile. So in order to say this one, then we are going to discuss about known as an efficiency, a group efficiency. Group efficiency represented with neta G. And this neta G is equals to whatever the load carrying capacity of group piles by N into Qi. N into Qi. Neta G is equals to Qg by N into Qi. This neta G can be less than 100% or more than 100% also. Sir, when it is going to be less than 100%, sir? Due to stress overlapping, and this can be seen in the case of the dense sands. What happens in the case of the dense sand? Occurs in dense sands and stiff clays. Have you remembered the chapter number 13? There we discussed about that when you shear a dense soil mass, what happens? Due to breaking of the interlocking, the particles will behave like a loose. Have you remembered that? See, for example, dense soil is there. And when you start driving the pile into the dense soil mass, what happens? Due to the disturbances, the soil will start to loosen. Interlocking between particles breaks and particles will loosen. So in the case of the dense sands and stiff clays, this group carrying capacity is going to be this group carrying capacity is going to be less than 100%. Why, sir? Due to interlocking between the particles, means due to the dense sands, due to the shear, the interlocking between particles will breaks, and what happens is particles gets loosened. Now this neta G is going to be greater than 100% in the case of loose to medium sands. Loose to medium sands. Sir, what happens in the case of the loose to medium sands? Sir? In loose to medium sands, while driving the pile, due to vibrations, compaction of soil occurs, or soil gets compacted, results in more load carrying capacity. More load carrying capacity. See, keep that in your mind. In the case of the loose to medium sands, while driving the pile, what happens is due to vibrations developed, the soil will get compacted and results in more load carrying capacity. That's the reason why that is known as densification. So due to densification of the soil, what is the meaning of densification? Compaction. So Qg is going to be more than or equals to N into Qi. When Qg is more than N into Qi, then the group efficiency is going to be more than 100%. So, but for in general, for analysis or for design purpose, we take neta G is equals to 1 or 100%. Then you are going to call it as optimum spacing. So now let me repeat the points again. Once again, you see, if there is a less spacing between the particles or piles, stress overlapping and disturbances are going to be caused, and which results less load carrying capacity of the group pile. And if there is a proper spacing is provided, which means wider spacing is going to be provided, soil between the piles and adjacent to the pile will get compacted or densified, then the load carrying capacity is going to be more than the individual piles. So whatever that ratio is known as a group efficiency, and that group efficiency can be less than 100 and it can be more than 100 also. Sir, you are saying the spacing. And what is the spacing, sir, we have to provide? Now there comes. Note. Generally, yes, spacing. Center to center, spacing between piles. Generally, for end-bearing pile, 2.5 times of dia of piles, which means S is equals to 2.5 D. And for friction piles, spacing is equals to 3 times of dia of the pile. And for the design, the spacing we are going to take a minimum of 2 to 3 times of the dia of the pile. So in the case of the end bearing piles, we provide a spacing which is equals to 2.5 times of dia of the pile, and in friction piles we provide a spacing for design. The normal spacing is going to be 3 times of the dia of the pile, Whereas in the case of the design, we take in general 2 to 3 times of the dia of the pile. So have a look once, then I go for the analysis. Okay, so these are the points that you need to remember in the case of the pile group. Now that's all about the group efficiency of, see, whatever this neta G is nothing but a group efficiency, right? Pile group depends on number one, type of soil. Number two, center to center spacing. C by C means center to center. C by C means center to center spacing between piles. Length of pile. Length of piles represents the stress overlap. Number of piles in a row and column. So it depends upon the type of soil mass, center to center spacing between the piles, length of the piles, and number of piles in row and a column. These are the main factors that the pile group is going to be depends on. Now let's see how to determine the load carrying capacity of a group pile. Determination of load carrying capacity of pile group. It is going to be QG. Okay. So now let's take with an example. I'll go with an example. I go with the example. So let's take an example. Example of 3 by 3 pile group. So let's take an example of 3 by 3 pile group. What is the meaning of 3 by 3 pile group, sir? Now have a look. In the plan view, this is a plan view. So this is one pile. There is one more pile. So this is a one pile, and likewise, let me keep that piles first, 3 by 3 pile group. Yes. So this is a 3 by 3 pile group over here. Now in the plan I am showing you here. Yes. So piles. Now in the section view, how does it looks like? In the section view, let's keep that aside. So in the case of the section view, what we are going to do here is in section. So we are going to plot the same. Now, okay. So this is nothing but the pile, and now wait. Sorry. Okay. So I hope you understood how the piles are going to be looks like in the plan view and in the case of the section view. So if this is a 3 by 3 pile group, now how to determine the load carrying capacity of this pile group? The load carrying capacity of this pile group means QG. How to determine this? Now let's say the center to center spacing between one pile. The center to center spacing between one pile is going to be S. If the center to center spacing between the pile is going to be S, then what is the dimensions of the pile group then? What's the dimensions of the pile group? Let's take it as B0 and L0. Keep this example aside. Now, you see, pile fails by punching shear failure. Punching shear failure. pile fails by punching shear failure. Yes or no? So as you know, in the case of the piles may fails by punching shear failure. So in pile groups, based on spacing between piles, based on spacing between piles. So if S is less than 2 to 3 times of the dia of the pile, soil will fails as a total block. Soil will fails as a block. Failure occurs as a whole block. Failure occurs as a whole block. You see, this entire block, what is this block? The block means in between the soil is also going to be comes into the existence. The entire block of dimensions B0 and L0, it is going to be punches. You know the punching shear failure. So the soil below the foundation is going to be under a lot of compression, and the entire thing is going to be moved vertically downwards. You go back to the chapter number 16. There I explained you the punching shear failure. And if the spacing is going to be less, now if the spacing is going to be less due to overlapping, the entire is going to be behaves like a single pile, which means the group is going to be behaves like a single block. I can say it as a block. So whatever this is going to be the block, the total is going to be block. The total is going to be block. And if spacing is going to be more than 8 times of D, if a spacing is going to be more, then failure if a failure happens, it acts as single or individual pile failure. So if the spacing is going to be less than 2 to 3 times of D, failure occurs as a whole block. And if the spacing is going to be more than 8 times of dia of the pile, if failure occurs, it acts as a single or individual pile. But no matter whatever the spacing it is, if you apply more load, then definitely soil is going to be failed. Yes or no? Yes or no? Yes. So now there are two types of failures. One is going to be block failure, and other one is going to be pile failure, mean individual pile failures. So pile group should design pile group should design for no block or individual mode of failure. For that, what we are going to do is, RSR, if the pile is going to be behaves like a block, if the pile is going to be behaves like a block, what is the maximum load that is going to be taken? I'm asking you once again, you please observe carefully. See, if the spacing is going to be less, then I told you it is going to be actually a block. And if the spacing is going to be more, then the piles are going to be actually like an individual. Then the piles are going to be actually like an individual. Now, just imagine, in this case, whenever there is a block, or whether it is going to be block or individual, now we need to know what is the maximum load carried by the pile group as a block and as an individual. Ultimate or load carrying capacity of a load capacity of group as block QGB, load capacity of group as single piles or individual piles, QGS. See, the G represents the group and B represents the block. G represents the group and S represents the single pile. So we need to find out both, when it is going to be acting like a group and when it is going to be acting like a block or single. So now let's see how to determine this. First, ultimate load carrying capacity of group as single piles. As single piles. So, my dear students, please observe over here as a single piles. QG of S is equals to total number of piles into individual pile. That's it. See, first one is what I am saying is if the pile is in pile groups based upon the spacing, the failure may be either block failure or individual failure. So what we are going to do is, what is the maximum load that the individual piles can take? And what is the maximum load that the whole as a block can take? That's what we are going to look over. Okay. So now you know how to determine the individual. You know how to determine the individual. So what is the QI over here? N into QI means FBAB plus FSAS. That's it. FBAB plus FSAS. So this is nothing but Q individual. Whatever the QGS is nothing but, whatever the QGS means whom? Capacity of group as a single piles is nothing but total number of piles into individual. So suppose there are, how many piles are there here? You please look over here. How many number of piles are there in this example? Total how many piles are there? 3 by 3, 9 piles are there. And this is one of the pile. What I am showing you, this is one of the pile in the plan view. And this is the section view. This is one of the pile. Now, each pile, if it is going to be actually like individual piles, then what is the total load carrying capacity of the group as a single? N into QI. So total 9 piles into individual pile. Sir, how to determine the individual load carrying capacity, sir? You know that in case FB is equals to CNC, where NC is equals to 9. Yesterday we have done this one. Yes or no? FS is equals to alpha into C bar. And in the case of sands, FB is equals to sigma V dash into NQ. FS is equals to K into sigma V bar into tan delta, and whereas AB is equals to pi by 4 D square, single pile, right? And AS is equals to pi DL. My dear, what is the difference that you have learned from the previous to this one? Tell me simply. What is the difference that you have learned from the previous to this one? The simple difference over here is just multiply with the M. That's it. Whatever the discussion I made, you see here. This is for class, and this is the individual or not? Yes or no? And now this is individual pile. What is the ultimate load carrying capacity of the individual pile, single pile? Now what I am doing is multiply with N. So whatever the earlier we know, multiply with n is nothing but the group carrying capacity of a single piles. So now this is a one ultimate load carrying capacity of group as a block mode. As a block mode. If I take it as a block mode, then what happens over here is, you see here, now the dimensions are going to be changes. See, if I take an individual pile, this is an individual pile. And what is the area of the pile? Area at base, pi by 4 d square. But now, if you take it as a block, then you have to take the whole. Then you have to take the whole as a block, a single block. Now, this is going to be block, and the dimensions of the block are going to be B naught and L naught. Sir, what is this B naught and L naught, sir? Now you see, sir, here. Sir, you please observe here. Everybody have a look. You see, whatever this is nothing but the half of the diameter or not. Whatever this is nothing but the half of the diameter. Whatever the nothing but the half of the diameter, where B naught is equals to, I can write, see how many number of spacings are there, please tell me. This is also one center to center spacing, and this is also half of the diameter. See, my dear students, how many number of piles are there? 1, 2, 3. 3 piles are there, then how many spacings are there? 2 spacings. Or if there are 3 piles, then there is a 2 spacings. Yes or no? If there are m piles, m minus 1 into, yes, spacing, plus at the edges, this is d by 2, and this is also going to be d by 2. D by 2 plus d by 2, d. Similarly, L naught is equals to n minus 1 into s plus d, where m comma n are number of piles in row and a column. See, this is a small n and this is a capital N. This is capital N over here, and this is going to be the small n. You please observe that. And this is how you are going to determine the B naught and M naught. So once you make it as a group or a block, now you observe what is going to be happen with the Q, G, B is equals to QB plus QS. Okay. Or I'll write over here. QGB is equals to FB into AB plus FS into AS. Look, the difference is in the case of the single pile, what is AB? Pi by 4 d square. Because for a single pile, if I take a single pile, whose diameter is going to be d, then what is area? And this is going to be L. What is the area at base? Pi by 4 d square. And what is surface area? Pi dl. But if I take the action as a block, then what is the area at a base? And now area at the base and area at surface, B naught into L naught. Why, sir? Because he is going to be actually like a block, right? And one more thing over here as AS. What is meant by areas? Pi dl, perimeter into length or not. What is the perimeter over here? 2 times of, or I can write this one as perimeter of group PG into L. So where AS is nothing but 2 times of B naught plus L naught into L. I hope you understood. So again, in case QGB is equals to CNC into AB plus alpha C bar into AS. But in the case of the groups, you have to take alpha as a 1. Why, sir? In block mode, shear mobilizes between soil adjacent and between piles. So we take alpha is equals to 1. What is meant by alpha? Adhesion factor or not? I told you adhesion is, you please go back. Yes, you see here, what is the CA? CA means alpha into C dash, adhesion. Are Baba, if there is a difference, if there is a different particles, pile and soil, then you get as a adhesion. But we are discussing about soil and soil, right? Then alpha is equals to 1. So in the case of the block mode failure, we have to take alpha is equals to 1. Why, sir? Whatever the soil mass here and whatever the soil mass adjacent to the pile, this is a soil mass adjacent to the pile, and whatever the soil beneath the pile, they are going to be between the piles, they are going to be mobilized. So alpha is equals to 1. Look, please observe carefully what is the difference between the block mode and failure, means block mode and a single failure mode. In the case of the single failure, I multiply with n number of piles. Just simple. Whatever you know earlier into multiply n. And in the case of the block mode, you are going to changing the area. Here the area is single pile area, and here the area is going to be group area. I hope you understood. This is single pile area and is going to be group area. So single pile area and here it is going to be group area. Now mind it, when you are going to design, are we going to design for the maximum out of these two or minimum out of these two? See, first finally I can say finally, I hope you understood how to solve this one. We'll solve also problems. Note. For example, let me take a QG of S as some 8,000 kilonewtons, QG of B as some 10,000 kilonewtons. Let's take, what is the meaning of QG of S? What is mean by QG of S? Load carrying capacity of group acting as a single piles, they can take only 8,000. They can take only 8,000. And QGB, load carrying capacity of group acting as a block, they can take 10,000, which means, so, I mean, I'm just taking the example. I'm just taking the example, which means as a block, it is going to be take 10,000 kilonewtons. And if you go beyond that, the soil will fail by block failure. And as a single, they are going to be behaves like the total piles can take 8,000 kilonewtons. The total piles can take 8,000 kilonewtons. So what happens over there is, in the case of the group, means acting as a single piles, 8,000. So the pile group cannot take more than 8,000. Now, if I design for the 10,000 kilonewtons, this 10,000 is more than 8,000, right? When the 10,000 is going to be more than 8,000, what happens? Then the piles are going to be fails individually, individual failure mode. But if I design for 8,000, for 8,000 single pile, no failure, and 10,000 is a maximum load for the block, so no block failure. So for no failure mode, for no failure mode, QG is smaller of QG of S and QG of B. QG of S and QG of B. Okay. And whatever the allowable safe group capacity, Q allowable is equals to QG by factor of safety. QG by factor of safety. And you know that factor of safety is equals to 2.524. That's it. Yes. Why alpha is equals to 1? Sir, shear mobilization between soil adjacent and between the piles. When the shearing is going to be between the same soils, alpha means same soil means adhesion or cohesion. Tell me. Same means between soil to soil means adhesion or cohesion. What is meant by adhesion? Attraction between different molecules. What is meant by cohesion? Attraction between same molecules. If the soil adjacent to the pile and soil between the pile, they are going to be mobilized. So finally soil is mobilizing. Then I don't need to take the adhesion. So I can take rightly alpha is equals to 1. In block mode, you have to take alpha is equals to 1. And the change in equation is going to be this areas, Nana. Please look over the areas. In the block mode, I took the block area as B0 into L0 and surface area as a perimeter of group into L. But in the case of the single mode, single piles, I can write single pile failure mode. I can write it as a single pile area. This is a single pile area if D is a dia of the single pile. If D is the dia of the single pile, and if it is a square, then you have to take it as A. Okay. So for no failure, QG is the smaller of QGS and QG of block. That's about the load carrying capacity of determine the load carrying capacity of pile group. The arching effect in the group of piles, there is no arching effect, so don't worry about that. Mobilizing means developing, Ray. How many times I say from the all the chapters mobilizing. Take alpha is equals to 0. When you take alpha is equals to 0, then cohesion is going to be 0. Alpha is equals to 1 means see the total adhesion or cohesion is going to be fully mobilized. In the case, okay, sir, what is the in the case of sands, the equation is going to be same. In sands, the equation is going to be same. In sands, the equation is going to be same. See the FB and FS in sands both are going to be same. But in the case of the clays, alpha is equals to 1. Even if they give alpha for block mode, you have to take alpha is equals to 1. For block mode, you have to take alpha is equals to 1. Okay, fine. Some of the people are asking, sir, what is a block mode in the sand, sir? So, okay, I'll write that also. In sands, block mode is equals to sigma V dash into NQ AB plus K into sigma V bar into tan delta AS, where AB is equals to B0 into L0 and AS is equals to 2 times of B0 plus L0 into L. I hope you understood now. Now, let's see the next one. In this, settlement in pile group. Settlement in the pile group. Now, my dear students, please tell me, generally what type of pile foundation will take as block or individual failure? I said you, it depends upon a lot of factors now. You cannot say directly. You have to say smaller of these two. I told you now, please look over this point. Now, you see, this is a settlement in the pile group. You see, compared to the individual pile, the pressure bulb of the group pile is going to be more or not? The pressure bulb of the group pile is going to be more, yes or no? See, compared to the individual pile, the pressure bulb of the group pile is going to be more, as a pile group is going to be more. The pressure bulb of group action of piles is more than individual piles. Is more than individual piles. So always settlement in a group piles is more than settlement in individual piles. You know that, see, always settlement in a group piles is more than the settlement in the individual piles. And you know that obviously the more the pressure bulb, the more the settlements. Haven't we discussed this topic in the previous chapter also? Yes. So there the settlement has an equation. Now, in the case of the pile group, what is the equation? In the case of the pile group, what is the equation? Let's see. For that, in shallow foundations and in deep foundations, I'll explain both. Already we have been there. Shallow foundations. In the case of the shallow foundations, I hope you remember. So if this is a load acting and if this is the depth of the foundation as D, width of the foundation as B, how to determine the ultimate settlement? Have you remembered the ultimate settlement, please? So yes, F is equals to CC by 1 plus E naught into H into log base 10 sigma naught dash plus delta sigma dash by sigma naught dash. I hope you remember this formulas. The same formula I am going to apply in the case of the pile foundation also. Wait for that. See if I can relieve it these two, then you can understand much more easy. Where you know that sigma naught dash means initial over burden pressure, and delta sigma dash means increase in stress due to external load. Yes. So I hope you remember all these points. Now you see why I take this one again is the only difference over here is if this is a clay layer and you know how to find out the CC, compression index, E naught, void ratio, and keep that in your mind. What is H? The H is going to be height of compressible clay layer. This is what we are going to look over here. This is what we are going to look over here in this. So now observe, in the case of the shallow foundations, the load is going to be assumed to transfer at the base. Yes or no? When the load is going to be allowed to transfer at the base, now whatever the thickness that you are going to see here, this is the thickness of the clay. This is the thickness of the clay, H. So, and you are going to determine the stresses at the center of the clay. And you know that sigma naught dash and delta sigma dash should calculate at the center of clay layer. I am repeating this why again there is a purpose over here. So here you can find out sigma naught dash and the delta sigma dash. And how you are going to find out the delta sigma dash? You know it clearly by means of 2 vertical to 1 horizontal distribution. This is 2 vertical to 1 horizontal distribution, and whatever this depth Z, this Z is going to be H by 2. So, and this width is going to be B plus Z. I hope you remember this. I hope you remember this. Yes. So now you see how I am going to replicate this one in the case of the pile foundations. In the case of the pile foundations, in case of pile foundations, settlement is going to be in group is determined same as raft. Raft means shallow foundation. But the point is in friction piles, the loading or raft is assumed at a depth of 2/3 of length of piles. See, in clays, this is in the case of the clays. In friction piles, loading, whatever the loading you are going to take, this loading is going to be there or not? Loading or raft is assumed at a depth of 2/3 of length of pile. Whereas in end bearing piles, equivalent raft is assumed at pile tip itself. So now let's see. I hope you know this point, right? Now it's all about the loading. Wherever the loading is going to be done, that's the point. And whatever the height of compressible clay layer means, the height of the clay which is below the base of footing, that is known as the height of compressible clay layer. So now let's see. First of all, in the case of the friction piles, no. Okay. First of all, if this is a clay layer, and this clay layer is going to be located up to this depth, let's say this is a clay layer. Please observe, I'm taking the same as earlier. You look, this is a pile cap, you know that. And if it is a frictional pile, in the case of the friction pile, now you see this figure and this figure. This is a shallow foundation, but this is a pile foundation, whereas in the case of the pile foundation, I told you, see, in shallow foundation, we assumed the load is going to be transferred at the base of the footing. Yes or no? But in the case of the friction piles, now what you are going to suppose to do is the raft is going to be act at a height of, the raft is going to be act So this is going to be the raft. This is an equivalent raft. Our loading is going to be considered from this point only. This is a equivalent raft. That's what I mentioned here. Settlement in group is determined same as a raft foundation, as shallow foundations only. But in the case of the shallow foundation, listen, in the case of the shallow foundation, load is transferred at the base, whereas in the case of the friction pile, now this is going to be present at a depth of 2/3 of the length of the pile. At a depth of 2/3 of the length of the pile. So whatever, this is nothing but 2 L by 3, and this is the remaining, this is going to be L by 3. So what is the basic difference between the shallow foundations and deep foundations is, in the case of shallow foundations, I assumed the load is transferred at the base. Load is transferred at base of footing. At the base of footing. Now here the load is going to be transferred at the equivalent raft. So my dear students, if you observe what is the thickness of the clay layer here is, I am going to take the thickness of the clay layer as this portion. I am not going to take the thickness of the clay layer from the pile tape. I am going to take the thickness of the clay layer. Why you take 2 thoughts are due to the friction effect? Due to the friction effect, it is going to be happen. So this is going to be the thickness of the clay layer. Now, where to find out the center is, this is the center, right? This is the center where Z is equals to H by 2. And here you are going to determine the stresses by means of 2 vertical to 1 horizontal distribution. So whatever this width, this is going to be the B naught nana. Whatever this width is B naught and this is B naught plus Z. You need to find out sigma naught dash and delta sigma dash. Same as earlier. Everything is same. The only difference that you are going to see here is in the case of shallow foundation, the thickness I took is at the base of the foundation. And here the thickness I took is below the ground level at a depth of 2/3 of length of the pile in the case of the friction pile. And end bearing pile, in end bearing pile, same thing. In the case of end bearing pile, okay. So now in the case of the end bearing pile, again this is going to be B naught, but this time in the end bearing pile, what is the meaning of end bearing pile, sir? In an end bearing pile, the load is going to be transferred at the pile tip directly or not? So what is the meaning of end bearing pile? Load transfers at pile tip itself, which means if I take the raft, this is going to be the equivalent raft. And whatever this is, if this is the footing, means hard strata, sorry. Now the thickness is going to be taken from the base of the raft. And we find out every stresses at the center of the compressible clay layer. So I hope now this is L, and whatever the load that we are going to calculate here, this is sigma naught dash, and here it is going to be delta sigma dash. This width is going to be B naught, and this is going to be H, and you are going to determine this again by means of 2 vertical to horizontal. This is again 2 vertical to 1 horizontal. 2 vertical to 1 horizontal. See, the only difference I have already mentioned here, in friction piles, loading is assumed at a depth of 2/3 of length of pile. And in bearing piles, equivalent raft is assumed at a pile tip. So whatever this is nothing but equivalent raft. Why I am writing equivalent rafts are equivalent means the same as the shallow foundation, and whatever the equation we have, SF is equals to CC by 1 plus E naught into H into log base 10 sigma naught dash plus delta sigma dash by sigma naught dash. So that's it. That's about the pile group. So I have been discussed about total things regarding to the pile group. Sir, is the equivalent draft assumed? Sir, assumed is na. You tell me. Assumption means is it virtual or real? Sir, please allow us to take screenshot. You turn page very fast. If power cut occurs, then don't tell us to send you. I don't tell you, but because I am using a different software, so I am not using the software which is going to be based upon the internet. So I am using another software. So now completed. If you have completed means if you have understood now. You see, there is one more formula for the determination of the so which is the determination of there is a one more equation converse Lebesgue equation or formulae. This is used to determine group carrying capacity, means to determine the group efficiency. We are going to use this one. So according to this, so now whatever the piles, where is the pile group? So if this is the piles, now if there are m number of piles in the row, see this is a pile group of m by n. M means number of piles in the row, n means number of piles in the column. Then the group efficiency is given as 1 minus theta by 90 degrees into m into n minus 1 plus n into m minus 1 by m into n. M into n minus 1 plus n into m minus 1 by m into n. If you observe here, see from the starting onwards I was discussing whenever I started the group piles, I was discussing about spacing defines everything. Yes. So you see, you go back over here. Let's go back once again here. You see, due to lesser spacing, QG can be less than n into QI. And spacing is going to be less, then the group efficiency is going to be less than 100%. If the spacing is going to be more, then the group efficiency is going to be more than 100% also. Yes or no? So now, my dear students, you observe in this equation given by the converse Lebesgue, you see whatever the number of piles m comma n, mn, I am going to take it as constant, and S is known as center to center spacing, right? Between piles. And how to find out the group efficiency here is, if you can find out the theta, see the m comma n values are going to be constant. And what is this theta, sir? The theta is equals to tan inverse of d by s. Tan inverse can also called as arc of tan. Tan inverse of d by s. theta is equals to tan inverse of d by s. So s center to center spacing between the piles, and whereas theta is equals to tan inverse of d by s. Now everybody have a look here. If you observe the theta and s, if the spacing between the piles is going to be more, if the spacing between the piles is going to be more, then the theta value is going to be less, because tan inverse of d by s, if denominator is going to be more, then the total value is less. Tan inverse of less value, which means theta value is going to be less or when the theta value is less, you see this is a coefficient m into n minus 1 plus n into m minus 1. This is constant. For a given pile group, this is going to be constant. And the efficiency depends upon the spacing, right? Yes or no? More the spacing, less the theta. Lesser the theta, and you are going to remove the less value. 1 minus less value will be more value, which means when the spacing is more, the efficiency of the group is going to be more. If spacing is less, theta value is more. If you substitute more theta, then this coefficient is going to be more. So then you have to remove more value from 1. If you remove more value, you get less value. That's it. So this is an empirical equation, Anna. This is an empirical equation. It's not a derived equation. This is an empirical equation. And for the derived equations, I have already discussed. I derived those equations also for you. That's about the group efficiency. And apart from this, there is one more rule, Feld's rule. And this Feld, this person says that, means all are representing the group efficiency only. This person Feld says that, Arey Baba, as long as you are single, you are highly efficient. And when you enter into the relationship with someone, then your efficiency and your capacity is going to be decreases. That's true, obviously. And if you enter into multiple relations, then your capacity is going to be much lesser. So, my dear students, as long as you are single, your capacity to achieve anything is going to be more. And once you get single, then it's up to you. So, the same thing said by the Felds. What he said is, if you take a pile, as long as the pile is going to be a single pile, which means if there is no neighboring pile, its group efficiency is going to be 100%. And if there is a neighboring pile, due to the neighboring pile, the load carrying capacity of a pile decreases by 1/16th of its initial. Sir, this does not apply for the 100%. Yes, my dear student, the converse library, I said this is an empirical. So now, according to the Feld's rule, what he said is, as long as you are single, which means if I take a pile, if I take a single pile, no. So this is only one pile, right? So single pile, its efficiency, let's take the group or individual ultimate load as going to be Q. The ultimate load carrying capacity of this pile is going to be Q. Okay. So whatever that's, let's say the ultimate load carrying capacity of this pile is going to be Q1 is equals to Q. But now, when you start to be a double pile, or now you see, now you observe, so you are single, your capacity is going to be more. Now, when this pile is going to be surrounded with the second pile. Now, due to this neighboring pile, your efficiency, the load carrying capacity of the pile, now it is no more Q. It is going to be reduced by 1/16th of its initial. What is 1/16th of initial? So now it is going to be 1/16 times of its initial, which means it is going to be having only 15/16 Q. And similarly, if you want to mingle with more people, then obviously you have to bear the issues. Yes. So now, if you see, I am going to give you 3 piles now. 1, 2, 3. This is one neighboring pile, and this is one more neighboring pile. See, if you are going to be having a relationship between means more than one person, then you have less time to manage with everyone, right? So I don't have that self experience. So if you do have, you know that, so how you are going to manage your time, and you have to spend less time with each and everyone. So your capacity is going to be reduced for yourself. Now, your capacity means a single pile load carrying capacity is how many piles are there? Neighboring piles, 2 piles are there. So 2 piles means 2/16, which means 14/16 times of Q. So now, if you observe, according to Fell's rule, due to neighboring pile, due to one neighboring pile, the load carrying capacity of a single pile reduces by 1/16th of initial. 1/16th of its initial. So this is what said by the Fels. So that's about my dear over here. So let's solve some questions regarding to this. With this, we have completed the single piles and group piles. Most of the concepts here has been completed, and there are some small topics will be left over. So now let's solve some questions. Yes, I am using Autodesk Sketchbook. Okay, let's see some questions. What is M and N? I told you what is M and N. M and N. Okay, fine. I'll write again over here. If you want to, M number of files in a row, and N number of files in column. This column over here is I take this as a row and this as a column. Row as a column. It's up to you. Whatever you want to take, you can take. Let's see some questions, please. So now let's come to this question. Question number 4. Yeah. A square group of 25 piles. Now, this is a square group. What is the meaning of a square group of 25 piles, right? 25 piles means if I say square group, the arrangement configuration should be 5x5 piles are not. So a square group of 25 piles, which is going to be 5x5, extended between depth of 2 meters and 12 meters. Mind it, the pile is going to be between 2 meters and 12 meters. So then what about the first 2 meters are raft? The first 2 meters would be the pile cap. The first 2 meters would be the pile cap. So what they mentioned is, if this is a ground level, in the first 2 meters, this is a pile cap, and the pile is going to be extended from 2 meters to 12 meters. Then what is the length of the pile? We have to take here as the length of the pile is 12 minus 2, which is going to be 10 meters. And it is a deposit of 20 meters thick clay overlying rock. So what is the soil mass here? Clay soil. And we don't need to worry about how much thickness of the clay, but we know the length of the pile. Piles are having dia. What is the dia of the pile? 0.5 meter. And spacing of the pile 1 meter center to center. The undrained shear strength of the clay at a pile base level is 180 kilopascals. And the undrained shear strength over the depth of the pile, I told you clearly yesterday, if I say you the pile level, pile tip, that is going to be C, and along the pile, that is going to be C bar, which is nothing but average, C dash. So what is the equation I have used? I think C bar, right? C bar, which is going to be 110 kilopascals. Now, the adhesion coefficient, what is the adhesion coefficient? 0.45. Estimate the ultimate capacity of the pile group considering NC for 5U is equals to 0 as 9. See, they're asking about QG. Okay, now let's see. Let's solve this. QG is smaller of QG of S, group and block, single and block. So find out QG, group capacity acting as single load, is N into QI. What is the total number of piles? The total number of piles is going to be 25 piles. Now, N into, this is going to be FB, AB plus FS, AS. So given is going to be clay soil, right? Then N into FB, CNC into pi by 4 D square plus alpha into C bar into pi DL. So now what is the QGS? The QGS is equals to, what is N value? 25 into C value. What is the C value? 180 into 9 into pi by 4 into D value 0.5 square plus what is the alpha value I have given? 0.45 into C bar 110 into D value 0.5 into L. So please tell me the QG of S value. Everybody, see, yesterday we solved this type of question, but now as it is a group, multiply with 25, because how many piles are there? 25 piles are there. What is the value, please, over here? $1130.63. Sir, you missed 5 value in the calculation, sir. Where is 5 value, sir? Where is 5 value? This is clear. Okay. So what is the value? Please tell me the value. 27,390.76. I think so. 27,390.76 kilonewtons. See, this is the total value that the pile can take if it acts as an individual. If it acts as an individual, it can take that much load only. Because you see, the spacing is going to be just 1 meter. What is the spacing you hear? You please observe. The spacing is going to be just 1 meter, which is going to be 2 times of dia. So what is a diameter? 0.5, and S is equals to 2 into 0.5, 1. Yes, means S by D is nothing but 2, right? Okay. Why I am saying this one? Just wait. Okay. Now, you please observe. Now for block mode of failure. For block mode, then QG of B is equals to CNC into A, B plus alpha into C bar into AS. I told you already, in the case of the block, you have to take it as alpha as 1. Now, what is AB? B naught into L naught. Yes. Now, for that, you see, how many number of piles are there? Total piles are going to be 25. Yes or no? So 5 by 5 pile group. Now, what is B naught is equals to L naught? Square configuration now. Then M minus 1 into S plus D. Square configuration. Which means B naught and L naught both are same. So B naught is equals to L naught is equals to 4 minus 1 into S plus 0.5. What is this value? 4.5 meters. So QG of B is equals to CNC into B naught square plus C bar into, what is a surface area? Na? What is surface area? Perimeter. Perimeter means 4 B naught into L. See, don't ask me, sir, why you take B naught is equals to L naught, because that's a square configuration. And don't ask me why you take B naught square. B naught into L naught, when both are same, B naught square, square. Okay, did I miss the pi value here? Okay, you sir, somebody said 5, though I didn't understand that. Yes, this is 5 into C bar into 4 into B naught into L. So now C value I have given you. What is C value? 180 into 9 into 4.5 square into C bar 110 into 4 into 4.5 into L. So please tell me this QG of B. Please tell me the QG of B. What is the QG of B? Please tell me. Yes. That's 5 only. B not 5. Yes, 5. 52,605. Yes. Yeah. So that's 5. 52,605 kilonewtons. 52,605 kilonewtons. So now you tell me what is the QGS? 27,390.76. And what is the QGB? 52,605 kilonewtons. And now as QG of S is smaller than QG of B, then QG is equals to 27,390.76 kilonewtons. That's the answer. So first of all, we are finding the individual failure mode, and then we are finding for the block mode. Then we are getting the load carrying capacity of the group, which is going to be smaller of those two. Answer is going to be 27,390.76. In examination, they will ask you 0 decimals or integer. If they ask you an integer, then you have to take it as a 27391 because you remove the decimals. Integer means there is no decimal, that's it. I hope you understood. Okay, fine. See this question. Question number 5. Okay, I'll do one thing. I'll leave this question number 5 for you. Here's a homework. But the point of here, optimum value of a spacing. Optimum spacing means group efficiency is equals to 100%. Optimum spacing is group efficiency is going to be 100%, and whatever the load carrying capacity of group acting as single is equals to load carrying capacity of group acting as a block. Both are going to be same. See, the meaning of optimum value of a spacing is, the meaning of optimum value of the spacing here is, the meaning of the optimum value of the spacing here is whatever the discussion we made, right? So QGS and QGB both are going to be same. You please find out the value. So I wrote here, where is that? Yes. For design purpose, we take neta G is equals to 100%. That is known as optimum spacing. So in that case, whatever the block QGB and whatever the single QGS, both are going to be same. And one more point in the question, they mentioned it clearly, neglect the end bearing. When you neglect the end bearing, then what is there only? Only skin friction is there. Neglect the end bearing means there is only skin friction. So you please try to apply this one, and you are going to get the relation S value, and S value is going to be present. You please go through the previous questions. Means I have given you the values. Now let me see this. Fifth question, S is equals to 2.180. So here S should be 2.180. This is the answer. You please try this. And now let's come to this question. This is the last classroom practice question. For the 3x3 pile group shown in the figure. For the 3x3 pile group shown in the figure, find the settlement of the pile group in a normally consolidated clay, NCC. See, they have asked the what is settlement of the group. See, they did not mention anything. When there is no mention in the question, take it as a friction pile. When there is no mention, see, if nothing is mentioned in question, let's go back. Yes, this is going to be applicable for friction pile and combined piles also. I did not say this earlier, sorry. So this is going to be applicable. This formula means this 2L/3 principle is going to be applicable for both friction pile and a combined pile. Yes. If nothing is mentioned in question, it is combined pile. So same principle as friction pile. The principle is going to be same for the friction pile also, means for the combined pile also the same principle. Now you please observe, we want to determine whom. So they mention the settlement of the pile group. I want to determine the settlement of the pile group. So what is SF CC by 1 plus E naught into H into log base 10 sigma naught dash plus delta sigma dash by sigma naught dash. So let's take this figure. Yes. If you observe, this one is going to be same as this figure or not? Yes or no? So now, can you please tell me what is the 2L by 3, please? What is the length of pile? 5 meters. What is the length of pile? 5 meters. Then 2L by 3 is equals to 2 by 3 times of, or okay, fine. 2 by 3 times of 5. What is this value, please? 10 by 3, which is going to be 3.33 meters. Then what is the H value? The H value is going to be, you please observe, whatever this is nothing but the H value or not. So the H value is going to be total 7 minus 2L by 3. The total depth I have mentioned you as 7 meters. So 7 minus 2L by 3, which is going to be 3.67 meters. 3.67 meters, and Z value is equals to H by 2, 3.67 by 2, which is going to be 1.83 meters. So first of all, you see what is the CC value? CC is given, yes. E naught is given, yes. H we find out just now. What is the H value? 3.67. Now our point is sigma naught dash and delta sigma dash. So let's find out the sigma naught dash first. Let's find out the sigma naught dash. So what is sigma naught dash? You know, initial overburden pressure at center of clay layer. Initial overburden pressure at the center of clay layer. So come on, please tell me, you see this equation, there is a water table here. As there is a water table, everything is going to be completely submerged. So now I am going to find out this point. Yes. So now you know that, can I write gamma dash into 2L by 3? You please look, this is going to be 2L by 3 plus what is this value? This value is going to be, see, we are going to find out sigma naught dash here. What is the total depth? The total depth is from here to here, 2L by 3 plus H by 2 plus H by 2. So they mentioned gamma W. Did they mention any gamma W? No, but given gamma side as 20. So 20 minus 9.81 into 12 by 3, 3.33 plus 1.83 plus 1.83. So which is going to be 52.61 kilopascals. Similarly, delta sigma dash is equals to, from 2 vertical to 1 horizontal distribution. From 2 vertical to, if they don't mention anything, then you have to go for the 2 vertical to 1 horizontal distribution. Now, you know that whatever the load they have given, Q is equals to 500 by B naught plus Z whole square. Because whatever this configuration is going to be square configuration, Arna. See, you see this configuration, square configuration. What is the square configuration over here? 3 by 3. So now you need to find out the B naught. What is B naught? M minus 1 into S plus D. Let's go back again. How many number of piles are there here? M is equals to 3. How many number of spacing should be there here? 2 spacings. So 2 minus 1 into, what is the spacing I mentioned? What is the spacing? This is a spacing. The spacing is going to be how much? The spacing S is equals to 0.5 meters plus the D value. You see this figure once again. This is the plan view, right? In the case of the plan view, I have given you the spacing 0.5 and diameter D is equals to 200 mm means 0.2 meters. So 0.2. What is this value, please? It is going to be like 3 minus 1. Sorry, 3 minus 1. 2 into 0.5, 1.2 meters. Now, delta sigma dash is equals to given Q value how much? 500 and Z value how much? 1.83. 500 by 1.2 plus 1.83 square. So which is going to be 54.46 kilopascals. Which is going to be 54.46 kilopascals. Now everything is there. Substitute in the equation. So substitute in the equation. What is the SF? Please tell me. CC value given as 0.027 by 1 plus E naught value. What is E naught value given? 1.05 into H value 3.67 into log base 10 sigma naught dash 52.61 plus 54.46. This is square, na? That's why we do by 52.61. Please tell me the SF value. So the SF value, what is the SF value? Please tell me. .419 meters or 0.15 meters. If they ask in the terms of the mm, that's going to be 150 mm. Sorry, 115, no? Yes, 150 on. mm or is it 0.149 or 0.0149? Tell me this. Is it 0.149 or 0.0149? I have my answers. Yes. This is 0.0149 meters. So, which is going to be 14.9 mm. If I can ask you with a zero integer, that is means integer, that is going to be 15 mm. Answer is 15 mm. So that's all with the classroom practice questions. And after the break, we'll see the other topics. I hope you saw this one, you understood this. So just simply by taking the Z value, we're going to find it. Now let's have a break. So we'll be seeing this value now. Let's have a break. Meanwhile, now it's 11:20. Come by 11:40. Come by 11:40. Meanwhile, try this. You know the converse Lebesgue theory, right? Apply converse Lebesgue principle. Everybody have, if you want, you can take the screenshot for the converse Lebesgue principle. Yes, you can take the screenshot over here. So for the converse Lebesgue, you can take it and you can solve that. Okay. Now I hope you have solved this question. So the answer should be group efficiency. The answer for this group efficiency 68.25% and load is going to be 6825 kilonewtons. Let's check it. You see the given piles are 4 by pi m by n is equals to 4 by 5 and theta is equals to tan inverse of d by s. Now, so they have given the dia as a 300 mm, which means 0.3 meters, and center to center spacing as 0.9, 0.3 by 0.9. Then you can find out the theta value. Once you find out the theta value, tan inverse of 0.3 by 0.9, which is going to be 18.43 degrees. So now, from the converse Lebesgue equation, 1 minus theta by 90 degrees into m into n minus 1 plus n into m minus 1 by m n. So which one I have to take as m, which one I have to take as n? It's up to you. You can take any one. So now 1 minus 18.43 degrees by 90 degrees into 4 into 5 minus 1 plus 5 into 4 minus 1 by 4 into 5. So 4 into 4 plus 5 into 3 by 20 into 18.43 by 90, 1 minus answer, which is going to be 0.68259. Okay, it's going to be simply 68.25%. In terms of percentage, I can take it as a 68.25%. In terms of percentage, 68.25%, and you know that group efficiency is nothing but group load by n into individual pile load. So capacity of single pile is given as 500, and they're asking determine efficiency and capacity of a freestanding pile group. So Qg is equals to neta g into n into Qi. So what is the number of piles then? 4 5s, 20 piles. Now you substitute that 0.6825 into 20 into 500. So which is going to be 6825 kilonewtons. That's the answers. These mains only, they won't ask this question in a prelims. Now, let's see the next topic. Next one, pile load test. Pile load test. This is a pile load test, and this pile load test is similar to the plate load test. So sorry sir to say this, you are going very fast today. No, I am not going very fast. Actually, I would be completing the chapter by this time, but I'm going slow only. I'm not going any fast. Pile load test. This pile load test is similar to plate load test. So similar to plate load test, however, we are going to do the plate load test the same way. We conduct the pile load test also. So this is a test pile, which is a timber pile. And so this is a test pile, and this test pile is going to be driven, and this is a test pile. We do the test pile with the timber pile. We are going to drive this pile into the ground level. Drive this pile into the ground level, and then by the support of the load mechanism, whatever, there is nothing but a hydraulic jack. There is a loading frame. There would be a small dial gauge. So this is a loading frame. There is a test pile. See, this is similar to the plate load test. I am not going to discuss too much into the test. Okay, fine. So now we are going to apply the hydraulic jack. Let's come to the procedure. This is hydraulic jack, and here it is going to be loading frame, where you are going to dump the loads on sand bags. So these are the loads. Now, what we are going to do here is again, a test pile is going to be driven into a test pile is driven into soil by applying loads in increments. Loads in increments. Now, as the pile settles, note down the settlement. Note down the settlement by means of the dial gauge. This is a dial gauge. Dial gauge by dial gauge at regular intervals. At regular intervals up to rate of settlement falls below 0.25 mm per hour. See, Just like in the plate load test also, we applied the load and then we understood the plate is going to be settled. Here, test pile is going to be settled. When the pile is going to be settled, then you note down the settlements until for a given load, you note down the settlements until the settlement rate is going to be falls below 0.25 mm per hour, which means almost it took a day. So once you note the loads, then what you do is you plot the table. You plot the table, whatever the load you applied, Q, and whatever the corresponding settlement. Once you plot the table, then you can find out the graph. Yes. Now where can I go? So let me remove that. So you plot the table over here. Once you plot the table, then you can find out the load, or you can find out, see, as you are applying the Q value, yes. So for the corresponding settlement, you can find out. See, once I plot the graph now, you know the graph, how does it looks like? If you see the graph, Q on x-axis, S on y-axis. So as it is a punching shear failure, you know that the graph is going to be looks like this. Punching shear failure. So in the same way we have discussed in the plate load test also, in plate load test, but in plate load test, we discussed about general shear failure and local shear failure. But in the case of the pile load test, we are going to discuss about the punching shear failure. And safe load is taken as minimum of. So my dear, can you see any sudden failure? No. Exact well-defined failure? No. So if you want to take the safe load, according to the IS code recommendations, safe load is taken as minimum of, number one, first let me write down, minimum of 50% of load corresponding to settlement as 10% of dia of pile. 50% of the load corresponding to 10% of dia of the pile. Generally, the dia of the pile testing, we take 150 mm to 200 mm, which means 15 centimeter diameter, 15 centimeter diameter to 20 centimeter diameter. Such a pile we are going to take. Now, you see, number one, 50% of load corresponding to settlement as 10% of the dia of pile. Second one, 2/3 of load corresponding to net settlement of 6 mm, and 2/3 of load corresponding to total settlement of 12 mm. Sir, what is the meaning of this one, sir? Please observe. Now, for the first one, you see on the x-axis there must be some settlement or not? Yes. If this settlement we take as a 0.1 times of d, what does mean by 0.1 times of d? See, the dia of the pile, whatever the dia of the pile I take, in this test, whatever the dia of the pile I take, and in the dia, 10% if I take it as settlement, which means, for example, if I take 150 mm dia, then 15 mm settlement. Yet a 15 mm settlement, 150 dia means 15 mm is going to be the settlement, whatever the load corresponding to this. And in this load, if you take 50% of the load corresponding to the settlement, that is going to be taken as a safe load. What is that? Safe load. Number one, 50% of the load, 50% of the load corresponding to a load which is going to be equals to the settlement as 10% of dia. Number two, if I take the net settlement, sir, what is mean by net settlement, sir? Look, listen. When you first install, the pile is going to be settled, or not? Yes, the pile is going to be settled. And when you remove the pile at the end, what happens? Or when the pile is going to be break, see, this pile load test is the most accurate. But destructive test. Timber pile fails, yet certain load and soil tries to regain and soil tries to swell. My dear, listen. Look, the meaning of net settlement is at some particular load, what happens is the timber pile is going to be failed. Up to that point, soil undergoes settlement, right? When the pile fails, then the soil starts to swell, which means whatever the elastic settlement, you know that any body has two settlements, elastic and plastic deformation. What is meant by elastic? When you remove the load, if the soil regains, whatever that regain is nothing but elastic. But in the case of the plastic, first you apply load, elastic, and then you apply load continuously, plastic. Plastic is a permanent deformation. Even after you remove the load, plastic settlement will be there. And that is known as net settlement. The meaning of net means plastic settlement. And the meaning of total is elastic plus plastic. That's all you require this. So in the pile load test, the safe load is going to be taken minimum of these three values. Please. Sir, there is a specific reason. The specific reason is for the hydraulic jug is it's not going to be impact the shock loads. It's going to be loaded by means of the gradual loading. So whatever the loads coming from the loading frame, now it takes the load and slowly it is going to be delivered to the pile. If you directly impound that, then there is a possibility the pile may break immediately. So this is about the pile load test. Yes. See, whatever the settlement you take, this is nothing but the settlement, no? And if this settlement is going to be, you take it as a 10% of the dia of the pile. 10% of dia pile means 0.1 D. For that, whatever the load is there, in that load, if you take 50%, that is a safe load. And when you remove the load, after the pile gets break, then the soil tries to regain some settlement or not. And whatever the leftover settlements would be there or not. See, this is the ground level. When you drive the pile, the ground level falls to this level from here to here. Okay. And whatever the settlement is known as a total settlement. And when you remove the load, now from here, it is going to be tries to regain some shape. Yes or no? It is going to try to regain some shape. And now whatever the difference I'm showing you, this is known as a net settlement, known as plastic settlement. So when you remove the load, the elastic settlement will regain, but plastic settlement would be there, and that plastic settlement is known as plastic means net settlement, and total means elastic plus plastic. So don't worry, see, in the case of the gate, there is no much of questions have been asked, and you don't need to worry too much into the procedure. In the case of friction settlement and end bearing settlement, do they indicate only block failure? No. See, I told you the settlements, my dear Kaushik, I told you the settlements in the group piles is more than the individual piles. So when the settlement is more, you want to look over the higher magnitude or lower magnitude, you tell me. When you design, you always go for the failure should be higher. So that is the reason why we took only settlement under group action. And in the group action, whether the failure is going to be block mode failure or individual failure, forget about that. That you get to know once you find out the ultimate loads of QGS and QGB. Now, comes next topic. Negative skin friction. So now the topic is going to be no, it's not a new chapter. Why you always focus on new chapter, new chapter, new chapter? When the new chapter start, again you will ask, sir, when the next chapter is going to be start? When the next chapter is going to be start, again you are going to ask, sir, what is the next subject? And when the next subject is going to be asked, means started, again you will ask the other faculties, sir, what is the next other subject? So that you will be busy in focusing about what is the next chapter, next subject, and next syllabus, and next gate also. And tomorrow will be our last day. Tomorrow is the last day of our class, and means for the gate people, and for ESE day after tomorrow. So now coming to the negative skin friction. See, this negative skin friction occurs, you see, observe. I mean, you see, now in the case of the negative skin friction, let's look. I've drawn this one, right? It won't take much time. Just give me a minute. Please. Now, observe, if this is a ground level, and now I am going to take our two soils over here. So if you look, I'll be taking this as a loose soil, and this is going to be a dense soil mass. So what is the meaning of a negative skin friction? Listen to the point clearly. See, when you drive a pile into a deposit where a loose sand or loose soil is located above the dense soil, the loose soil will undergo the settlement. Yes, due to the vibrations, the loose soil also starts to move downward. And whenever the loose soil is going to be moved downward, then it is going to be create a downward drag, right? Yes or no? Means when a surrounding soil, when a soil surrounding pile, when a soil surrounding pile settles more than pile, more than a pile. So whatever the soil mass which is surrounding the soil, if it is going to be settled more than a pile, then soil induce a downward drag. Soil induce a downward drag on pile known as negative skin friction. Negative skin friction. See, keep in your mind, my dear, when a soil is going to be, when a soil surrounding the pile settles more than the pile settlement, then it is going to be induce a friction which is going to be downward, because I am a pile, this is a soil. If the soil is going to be settled suddenly, then it is going to be created downward drag or not, and that downward drag is known as negative skin friction. Sir, what is the meaning of the skin friction normally? Skin friction is going to be resistance or not? You see, this is a dense soil, and in the case of the dense soil, there is a friction which is known as a skin friction. This is QS. And what about here? This is known as a QNS. The QNS is known as a negative skin friction. Sir, can we see this negative skin friction everywhere? No. This negative skin friction, this phenomenon can see if a loose soil present above dense soil, or if top layer or top soil is recently filled up soil. Recently filled up means a loosest state, right? Or if a compressible clay layer or consolidating clay layer present above incompressible soil. See the point I am mentioning in all these things. If you observe, if a loose soil is going to be present, the loose soil will move downward and the dense soil will resist. Loose soil and dense soil. Top layer is recently filled and it will move down. And if the above layer is going to be compressible clay or clay is undergoing consolidating, then you know that what is meant by consolidation? Settlement will occur or not. So the output should be the surrounding soil should settle more than the pile. Then you are going to say the relative movement of the pile and soil will cause a downward drag, because pile is moving downwards, soil is moving downwards, both are moving downwards, then the action is going to be downwards. Now, My dear student. And one more thing, I can give you one more example here. Lowering of groundwater table results in settlements. You know the meaning. If you want, you please go back in chapter number 11. When the groundwater table lowered, if water table lowered, effective stress increase. When effective stress increase, settlements are going to be increases. If you have a doubt, please go back to the chapter number 11. There I have discussed with respect to examples also. Now, these are some of the reasons where you can see the negative skin friction. And now you see, as it is a downward drag, this negative skin friction will definitely reduces the capacity or increases the capacity. Look, generally in this zone, it should be more, means there should be resistance, yes or no? But as the soil is moving down in this zone, let's take the length of the skin friction as LC, negative skin friction as LC. What is LC? Length up to negative skin friction is going to be present. Then in this zone, there is no resistance. Instead of resistance, it is going to be cause of failure, which means load carrying capacity of pile decreases. The load carrying capacity due to skin friction, I can write that, due to negative skin friction, the load carrying capacity of the pile is going to be decreases. Sir, how come I remove, sir? If you provide a steel casing, then you can remove that. And if you provide any lubricant or a diesel lubricant on the sides of a precast pile, whatever the driven piles would be there on that, while you are driving, if you provide a grease to the sides, then that grease will cause no friction between the soil and pile. Then the soil won't move. So this is known as negative skin friction. And the important point over here is, when a soil surrounding pile settles more than pile, then it is going to be induce a downward drag known as negative skin friction. And due to negative skin friction, load carrying capacity of pile is going to be decreases. Now this phenomena can see now, these are the reasons behind it. Is it necessary to have a dense soil? Yes, if you have a dense soil, then you can know up to what depth the negative skin friction is going to be. Fine. And now let's see. Determination of negative skin friction. For a single pile, in the case of the single pile, my dear fellows, you please observe what is the difference between QS and QNS. Listen, I'm not completed yet. I'm not completed yet. Listen, see the difference between the QS and QNS is the direction. In the case of the QS, it is going to be upward direction, means resistance. In the case of QNS, it is going to be downward causing. But both are acting along the surface area or not? The surface area, which is nothing but negative skin friction, right? And that is going to be up to a length of LC. Now, this equation is in the case of the single pile, QNS is equals to skin friction, which means alpha into C bar, but area is equals to pi d into LC. This is for clays. Same equation. What is the skin friction? Pi d into total length, right? Pi d into total length. But see, I'm looking over the magnitude. I have already told you that sign. Now I'm looking the magnitude. The magnitude is, this is QNS, which is going to be downward, right? So now pi d into LC, which is going to be clays. This is for the clays. Similarly, K into sigma V dash into tan delta into pi D into LC, where sigma V dash is average vertical stress up to depth LC. And how to find out that average vertical stress, sir? That average vertical stress please observe, this is LC and here is going to be gamma into LC, right? That's going to be gamma into LC and here is going to be 0. So what is average? Gamma into LC by 2. What is average? Gamma into LC by 2. The same equations, if you observe, I'm not changing any equation. The equations are going to be same, but due to the downward movement, it is no more resistance, it is going to be causing, so that much amount of the load carrying capacity will decrease. I hope you understood. Where LC is then up to which negative skin friction exists. So what if we replace the loose soil with upward seepage condition with soft sand? You please try to do it, Mr. Kaushik. Arching effect will be happen up to certain depth DC. Why? Okay, fine. Now, in the case of the group piles, if it is a group pile, let's copy that somewhere. Now, in the case of the group pile, if you observe, so now so now you please look, let's say there is a negative skin friction up to this level. So in the case of the group piles, let's say this is a loose soil and the depth it is going to be there is up to LC. See, in the case of group pile, what happens is whatever the entire block is going to be either resist or they are going to be fall as an individual. So see, in these group piles, the negative friction can be taken along an individual pile, just like the group pile load carrying capacity I have discussed or not. So here the pile action, group piles action as single pile, the group piles actions are going to be like Qn, negative skin friction of group, or Qgn of S, negative skin friction in group piles acting as a single pile, and Qgn of B, negative skin friction in group acting as block, acting as a block. So now, my dear, just similar way earlier, however, we have written negative skin friction of a single, just how many number of piles into QNS. So n into alpha into C bar into pi d into LC. That's it. Where n is the number of piles. Where n is the number of piles. See, if you do remember it as a separate formula, you will definitely forget about that. I'm telling you, whatever the single pile I have written over here, this is nothing but the skin friction only. You keep that in your mind. Negative skin friction and skin friction formula is same, but what is the difference? The length. If you take the total length, that is the skin friction. If I ask you the means, if I go for the LC, that is going to be negative skin friction, right? And if it is a Qgn of block, then you have to write this one as friction force on block plus weight of the soil in block. So whatever this is, now if I take this as a whole block and this is going to be the soil, right? And definitely due to that soil, there is some weight. So whatever the weight of the soil and whatever the friction force developed, negative friction developed along the block. So in this case, what we are going to see here is Qgn of B is equals to friction force alpha into C bar into, now it is block. What is the block area? Area of block is equals to B naught into L naught, and area surface is nothing but perimeter of the group into LC, where PG means perimeter of group. Yes. So AS plus weight of soil plus weight of soil. Now you know that in block mode alpha is equals to 1. If you have the reason, you please go back and get the reason. C bar into perimeter of the group. What is the perimeter of the group? What is the perimeter of the group? Perimeter of the group means 2 times of B naught plus L naught. I don't write that. I will just write it as area of the surface, which is going to be perimeter of the group into LC. Sir, why you are not writing A is directly, sir? Sir, now surface area S means here up to negative skin friction plus weight of soil can be written as density into volume, and that volume is equals to area of the group or area of the block. Whatever this is nothing but area of the block or area of the group into LC, where area of the group is nothing but B naught into L naught. So now I can write directly QGN of B is equals to C bar into surface area, which means perimeter of the group into LC, plus gamma into AG into LC. So this is the final equation. In the case of negative skin friction, this is individual wherever this is individual and here this is going to be the block. Now, my dear, while I was taking the group load, yes, I took the QG is smaller of QGS and the QGB. What is meant by QG over there? Load capacity, which is a resistance or not? That is the resistance. Now, in the case of the failure, you see this negative skin friction is a failure, right? As a negative skin friction is a failure, then you have to take the negative skin friction as means whatever the QGN group negative skin friction is larger of QGN of a single mode failure and QGN of block mode failure. So for single mode, yes, for block mode, N. Again, what is the extra topic that you are going to learn here is in the case of the negative skin friction. So if you multiply with N into each negative skin friction, that is going to be single mode failure. And for block mode failure, you take alpha 1. Apart from that, the extra term you are going to see here is a weight of the soil in the block. Whatever, this is nothing but soil or not. And this soil must be having some weight. So how to determine that weight? Unit weight into volume. What is volume? Whatever the area of the group. Whatever the area of the group into what length you are going to see? LC. So with this, we have completed the negative skin friction. Negative skin friction. I hope you understood. Yes. Okay, fine. Now let's see a question, previous gate question based upon this. Let's solve the previous gate question. So my dear fellows, please have a look. A group of 9 piles in a 3 by 3 square pattern. A group of 9 piles. See, piles are 9 piles. N is equals to 9 piles. And what is the pattern? 3 by 3 pattern is embedded into soil strata comprising dense sand underlying a recently filled clay layer. See, this is a recently filled clay layer and this is a clay layer, right? This is the recently filled clay layer and this is going to be the dense sand. So now there is a clay layer up to length LC. What is the length LC now? 2 meters. Because I told you negative skin friction occurs in the top soil mass if there is a recently filled up soil mass. And the perimeter of an individual pile. So the perimeter of an individual pile, pi d, is given as 126 centimeters. Keep that in your mind. Perimeter of an individual pile. What is the meaning of individual pile? Pi into d. Okay. The size of the pile group The size of the pile group is going to be 240 centimeters, which is going to be, see, they have given this is a 2.4 meters, which means B naught is equals to L naught is equals to 2.4 meters. And the recently filled up soil has an undrained shear strength of 15 kilopascals. So what is the undrained shear strength in the case of clay? The undrained shear strength means Cu 15 kilopascals and unit weight is 16 kilonewton per meter cube. The negative frictional load acting on the pile group. First of all, negative skin friction acts in the case of this portion only. This is the negative skin friction portion. So now as it is a group, now just now I have explained, right? This is a perfect example for that question. I'm telling you, this is GATE 2018 set 2 question. You please observe here. I'm providing you GATE 2018 set 2 question. So if you have any doubt that some of the people, sir, perimeter is pi d, sir, surface area means pi dl, sir. Now, single failure mode. In the case of the single failure mode, then QGN group negative skin friction acting as a single N into alpha into C bar into pi d into LC. Alpha is not given. When alpha is not going to be given, take alpha is equals to 1. Assume alpha is equals to 1. Because as they have not given the alpha, right? As they have not given the alpha, so I can assume it as 1. So if they don't mention the alpha, you take it as 1. Now, 9 into 1 into, what is C? This is a uniform deposit, now. Whatever this is, C bar is nothing but 15 into pi into, what is D value? That okay. You don't need to write this one because you know the pi D value is going to be 126, right? Which is 1.26 meter, I think so. 126, yes. 1.26 into, what is LC? LC is going to be 2. Please find it out. 9 into 1 into 15 into 1.26 into 2, which is going to be 340.2 kilonewtons. Now, block failure mode. So QGB of Q group negative acting as a block. Block means you know that C5 into perimeter of group into LC plus weight of soil. What is the weight of soil? See, if you don't want to remember the formula, you remember as weight of soil. And what is weight of soil? Unit weight into volume. Volume means Ag into LC. Gamma into Ag into LC. First of all, you find out the perimeter of group. What is the perimeter of group? The same, right, which is going to be 4 times of B naught, 4 into 2.4. What is this value, please? 9.6 meters. Area of group B naught square, 2.4 square, 5.76 meter square. So now you substitute QGN of B is equals to 15 into 9.6 into 2 plus gamma 16 into area of group 5.76 into LC2. Tell me this value. Which is going to be 472.32 kilonewtons. So as they're asking up to 2 decimals, so now, as you know, just now I mentioned, as you know, QGN is a larger value. So what is the answer? 472.32 kilonewtons. So that's about the negative skin friction topic. So I have given you the whole nature of the negative skin friction and how to determine the negative skin friction in the case of the simple piles. Please have a look once. Give me a minute, I'll bring some. Why larger means, see, as a design, when we discuss about failure, we always go for the larger values. And when we design about the load that we take the smaller value. That's nothing but so see the safe values. When we are discussing about resisting, we always lower our resistance. Means we say my resistance is less. So when you feel the resistance is less, then you apply less load. But when we discuss about failure, always we discuss about the maximum amount of the failure, because when it's a failure, you have to look over the maximum side so that you can design that. So that is the reason why the negative skin friction is a larger value and load carrying capacity is a smaller value. So I hope you have seen that. Now let's see. This is one of the previous gate question, gate 2017. So now please observe. Two identical concrete piles having the planned dimensions 50 centimeters by 50 centimeters. The planned dimension is 50 centimeters by 50 centimeters are driven into homogeneous sandy layer. This is a sand deposit. Okay. But you see here and here, this is a water table, right? If QP1 and QP2 represents the ultimate point bearing resistance. See, they gave bearing resistance. Understood? What is the meaning of bearing resistance? Then QU is nothing but QB. So which is going to be given as QP1. Now bearing resistance. So you know that then QP is nothing but what is the bearing resistance in the case of sandy soils? In the case of the sandy soils, you know that sigma V dash into NQ into AB. Okay. Now same soil, same sand, same phi, NQ is constant because you know that NQ depends upon whom? Phi value. Okay. Now same pile dia, so AB is going to be constant. Okay. Now same pile length, L is going to be constant. L is constant. So L is constant and DC is also going to be constant, right? If there is a DC, what is meant by DC? Critical depth. In the case of the sands, so there is a critical depth, right? But now you see QP1 is equals to QP1 or I can write directly QP directly proportional to sigma V and QP1 is equals to gamma, this is gamma into 20. QP2 is equals to gamma dash into 20. Or let's take it as DC only. Let's take it as DC only as or I can write directly. QP is going to be directly proportional to sigma V. And as the DC is not mentioned, see this is 20 meters, right? So assume DC is less than L. So gamma into DC, gamma dash into DC. Again, the soil is going to be sand, right? Then QP2 or QP1 by QP2 is equals to gamma by gamma dash. And you know that what is gamma here? 18. What is gamma dash here? 19 minus 10, which is going to be 2. So what is the meaning of 2 here? Please tell me. What is the meaning of here? Please tell me. So QP1 is equals to 2 times of QP2, which means QP1 is greater than QP2 by about 100%. I don't need to solve this question this much length. I'm just saying you for the sake of you. I say array sand same, phi same, NQ same, pile same, area is going to be same, area same, NQ same, length same means then NQ is also, sorry, gamma, L is also going to be same. When water table changes from here to here, you see there is no water table, but here there is a water table. What happens? Gamma changes to gamma dash. That's it. So the QP1 is equals to 2 times of QP2, means twice. Twice means so more than 100% means exactly 100% more. Answer is yeah. Foundation engineering was not difficult. I am taking the difficult gate questions. I am taking the typical gate questions that you cannot get into one time. So that's the reason why you might feel that. Now this is one of the previous gate question. You see this question please once. So now come to the gate 2009. This is a gate 2009 question. If you see whatever, there is nothing but loading platform. See pile load test, just simply it's going to be a pile load test, and we are going to insert that pile of 5 meters. What is the length of pile? 5 meters. I gave you dia of the bored pile. See what is the diameter? 0.5 meter. And angle of friction here, pile friction delta 24. At the pressure coefficient they have given 1.5. And whatever the soil data given as gamma sat means water table is here, phi given, C given, NC given, gamma W given. Now see the question what they are asking. The maximum pressure that can be applied with the factor of safety of 3 through the concrete block. Keep that in your mind, they are not on the pile. See, this is just to fool you, to make sure you fool you. Here there is a shallow foundation, there is a deep foundation. You see, this is just nothing but a shallow foundation looks like. Yes or no? And whatever, this is nothing but the concrete block or not. This is a concrete block and it has been clearly mentioned. Now let's take the concrete block outside. And what is the dimensions of the concrete block given? This is going to be 1 meter. And this is going to be 1.5 meters. And here, okay, yes, this is going to be 6 meters height. So now there is a concrete block of width 1 meter. Now, what is the pressure that can be applied with the factor of safety through the concrete block? What is the pressure that you can apply? Q. You know the design condition, safe condition. You remember Q is less than or equals to QS. Q is equals to QS. Whatever the soil here, this soil is going to be sandy soil or not? Sandy soil. Yes. Now, my dear students, you see, as the concrete block is on the ground surface, as block is on ground level, D is equals to 0. So using Terzaghi's capacity equation, bearing capacity equation, without considering the shape factor, see, they are not asking anything regarding to pile. They're asking now, this is a concrete block. And through this concrete block, what is the pressure that is going to be taken by the soil mass? So now at the ground level, the D is equals to 0, which means no surcharge at all. No surcharge. When there is a 0, then please observe. So this is question number 1, Nana. In that question number 10, this is question number 10. Now, what I do is, as you know, Q is equals to QS. And what is QS? QNS by factor of safety plus gamma D. D is equals to 0. What is QNS? What is this QNS? QNU by factor of safety. What is this? QU minus gamma D by factor of safety. Again, D is equals to 0. And QS is equals to QU. See the concrete block. What is a concrete block? What is a concrete block? The concrete block is going to be, what type of a foundation it is? Is it a square or rectangle? A rectangle. Rectangle of 1 meter by 1.5 meter. Okay, so now as the soil is going to be C0, cohesion effect gone. See, now I am not going to write anything. Neglected. D0, surcharge, neglected. And what is the only thing that is going to be there here is, the ultimate bearing capacity 1/5 into, see, I think, I'm sorry, this is 1.5 meter. And this is going to be 6 meters length. Look here, length is going to be 6 meters, width is going to be 1 meter. I told you when length is going to be much more greater than B, that is going to be a strip footing, right? That's going to be a strip footing. So in the case of the strip footing, now 1 by factor of safety, then QU is equals to cohesion effect gone, surcharge effect gone, 0.5, and moreover, there is a water table, right? Gamma dash B and gamma. So up to this point, I have applied just a concept. I did not apply any question. Now, let me go back once again. What is the question they are asking is maximum pressure. What is meant by maximum pressure? Gross pressure. That can be applied with a factor of safety of 3, which means Q with a factor of safety, you know, when I say factor of safety, that is known as design condition. Q is equals to QS. When Q is equals to QS, then as block is on ground surface, no surcharge. D is equals to 0. D0, surcharge neglected. And in the question, I mentioned C is equals to 0. What is meant by C0? Cohesion is going to be 0. When cohesion 0, cohesion effect is going to be neglected. What is the only thing? Width. And moreover, there is a water table at the ground surface. As there is a water table at the ground surface, so gamma dash. So please substitute these values now. 1 by, what is the factor of safety? See, if you are going to solve more number of questions now, then you don't need to write all these equations also. You can say directly, oh, okay. See, by seeing the logic, what is the type of soil? C0, cohesion effect gone. Block is on whom? Ground level. D0, depth effect gone. Then what is the only effect? Width effect. And as it is a strip footing, width effect, what is the effect of 0.5 gamma B and gamma? What a table, gamma dash, and you apply the factor of safety. 0.5 into gamma sat is 18, gamma dash is going to be 8. And width 1 into, what is the value? 40. Please tell me this value. Yes. So now, what's the answer you got, please? I think it's going to be 53.33. 53.33 kilopascals. Here, nearest value is 60. Answer is 60. Answer B. Now, the maximum resistance offered by the soil through the skin friction. The maximum resistance offered by the soil through the skin friction while pulling out the pile from the ground. See, while you are pulling out the pile or while you are driving, there is a skin friction or not. What is the maximum skin friction? Now, the next question, 11. So they're asking skin friction QS. What is that? QS is nothing but the soil is what type of soil? Please tell me. Sand, right? In sand. And in the case of denser sand, that too. In denser sand, QS is equals to K into sigma V bar into tan delta into pi DL. So come on, as you know, DC is going to be 20 times of dia of pile. They did not mention, right? So these type of questions, you have to remember those values for the checking. Look, 20 into dia of the pile. What is the dia of the pile they have given? 20 into 0.5, which is going to be 10 meters. But given L is just 5 meters. So, which is going to be less than DC, which means L is less than DC. So, when L is going to be less than DC, now you know that there is no arching effect. Up to DC, the stress varies linearly. So, up to L is equals to 5 meters. What is this value? Gamma into L, gamma dash into L. What is a gamma dash? 8 into 5, which is going to be 40. Then what is average? Average is equals to 0 plus 40 by 2, which is going to be 20 kilopascals. And given delta, what is delta value given? The delta value is given as 24 degrees. And earth pressure coefficient given as 1.5. So now, in the case of the denser sand, I told you already the DC is equals to 20 times of dia of the pile. So now, if you observe, substitute QS is equals to 1.5 into 20 into tan delta 24 degrees into pi into what is dia? 0.4 into L into 5. Please tell me this QS. 20 into 5 into 0.5 into 5 into 1024, which is going to be 104.9. Yes, 104.9 kilonewtons. Answer is A. Please have a look. I told this point earlier itself. If you want to look, you can look. Yes, here you see I have already mentioned this point. When the length is going to be less than DC, then at pile tip you have to take it as gamma dash into L. We'll go through this. There is a one topic left over in this chapter under removed piles. So the topic should be completed, but haven't. There is nothing confusion over here. See, the first question they are asking about the concrete block, and the concrete block is going to be just over here, right? Why I take this as a shallow foundation is when the depth is less than or equals to width. You tell me D less than or equals to width. What is that foundation? Shallow. So now you know that as D is equals to 0, then I can use this one. Yes. I took the area of the triangle. What is the area of the triangle? Please tell me. Hey, see, average, that's pressure is area of the triangle. Average is see 0 plus 40 by 2. That is weighted average. Weighted average is different. Weighted average means average into particular length. How to remember these many logics? Then if you solve, if you go through that, see, just imagine these many chapters, these many days we spend, and if you feel the subject, see, actually I can feel the out of all the civil engineering subjects, I feel the soil mechanics and foundation engineering is going to be very typical. At the same time, I feel it is very easy also. Why it is typical is too much of topics, but why it is simple is the way that we understand, the way that we can analyze, the way that we can take, and the way that we can think, and the way that we can imagine. See, each and every chapter and each and every topic I have taken, every topic, wherever there is a concept, I explain from the root level to the basic and basic to the advanced level also. Okay, fine. I do one thing. I'll stop for today, but I'll take the doubt clearing session. I'll take the doubt clearing session now. And if you people are willing, under removed piles, it won't take much time. Please, if you spend 15 minutes, then we can complete the under removed piles so that we can complete the chapter. See, spend 15 minutes, we can complete the under removed piles, and that is the end of the chapter. So why to leave the chapter abruptly? Sorry, abruptly. We will complete that chapter and we can complete the syllabus. So we can complete the syllabus, that's the reason why. Okay. Under removed piles. The last topic in this chapter, the under removed piles. It's a simple topic only, it won't take much time. So don't worry. Whatever the known points, will complete, and those who wants to, already some people has left, so if you want to leave, you can leave and you can see the recorded video, but I want to finish this chapter so that we can start everything afresh tomorrow. So now, in the case of the under removed piles are also known as bored or bulbed piles. Bulb piles. See, these are generally bored piles with a bulb underneath. So now bored piles with a bulb underneath. So now if you see, how does this bored pile looks like, sir? Yes. So if you see, you can observe this one as see, whatever this is nothing but the bulb over here. Whatever this is nothing but the bulb over here, and is the ground level. So in the case of the under removed pile, whatever the load, this is known as a under ream. And this under ream is nothing but a bulb. What we call is a bulb, and this is nothing but a pile shaft. These are pile shaft. See, these bored piles are underneath piles. These are known as a bored piles. You cannot drive these piles. So these are bored piles with a bulb underneath. So what happens over here, sir? Here, due to this bulb, the bearing area is going to be more. Let's take dB is the dia of the bulb and D is the dia of the pile. If dB is dia of bulb and D is dia of pile shaft. Generally, these type of piles are used. It can be done in sands and clays, but useful in expansive soils to reduce swelling and shrinkage. Sir, why they are going to be reduce the swelling and shrinkage? See, they are going to be useful in the expansive soils and useful in the expansive soils to reduce the swelling and shrinkage. See here, Due to this load, not only here, there is a resistance provided over here on the bulb portion also. Yes. And this bulb provides an anchorage towards the swelling and a shrinkage. So here, under rim provides anchorage towards expansion or uneven volume change. Uneven volume change. Under rim provides anchorage towards the uneven volume change so that it can reduces the uneven swelling and shrinkage. So, and it improves load carrying capacity of pile. Look, compared to straight bored pile, if you provide a boring over here, it improves the load carrying capacity of the pile, mind it. Sir, if you increases the load carrying capacity of pile, it is going to be much more useful or not. So you can use it for any type of soil, but mainly useful in the expansive soil to reduce the swelling and shrinkage. And if bulb is increased from 1 to 2, at a time. If bulb is increased from 1 to 2 at a time, the load carrying capacity of pile increases by 50%. So, see, point number 1, in the case of negative skin friction, the load carrying capacity decreases, but in the case of the under removed pile, due to this under rim, what happens is the load carrying capacity of the pile is going to be increases. And if you provide one more bulb, then mind it, its capacity is going to be increases by 50% more than the initial. So its capacity is going to be increases by 50% more than the initial. So how the boring is going to be done? By means of the auger boring. Earlier I told you now. So yes, it is the same way. And here you are going to provide one more bulb and you are going to remove the soil here also. The same way. Then you are going to fill this and this is going to be the bulb. Now see the initial length of the bulb is going to be, see, first bulb should be at a depth of 1.75 meters or 2 times of dia of the bulb. Generally, dia of the bulb is 2 to 3 times of dia of the shaft, which means we take it as 2.5 times of dia of the pile shaft. Generally, we take the dia of the bulb as a 2 to 3 times of the dia of the shaft. See, all these points are previous ESE questions only. All these points are previous ESE questions. So you please go through the previous ESE questions and then you can get to know that. If bulb is increases from 1 to 2 at a time, load carrying capacity of pile increases by 50%. And generally, the dia of the bulb is going to be 2 to 3 times of dia of the shaft. dV is equals to 2.5 times dia of the shaft. And the center to center spacing between bulbs should not less than 1.5 times of dia of bulb. Should not less than 1.5 times of dia of the bulb. See, these are going to be things, sir. How it is going to 50%, sir? From the field test, it was observed. If you increase one bulb at a time, then definitely the load carrying capacity is going to be increased by 50%. Sir, how a bulb can reduce the swelling, sir? Now you see, sir. See, what is the meaning of the soil mass or swelling moving upward or not? Now, when the soil is moving upward, this bulb is going to be provide a bearing resistance or not? See, this is nothing but anchorage resistance. Are Baba, if this is going to be resist, then the soil will not swell below the bulb. Yes or no? And when the soil tries to shrink, and this bulb is going to be present, and this bulb will not allow the soil mass to shrink, and it is going to be provide anchorage. So above anchorage to the shrinkage, below anchorage to the swelling. That's how it's going to be done. And now, how to determine the load carrying capacity in the case of the under removed piles? The load carrying capacity of under removed pile is similar to static formulae. Static formulae. You see, if bulb is located just above tip, if bulb is located just above pile tip, please observe. See, if the bulb is going to be located just above the pile tip, now let's take this is the length of L here. Now, how to determine the ultimate load carrying capacity? If bulb is located just above the pile tip, stem projection below tip is neglected, which means this portion is there or not, this portion is going to be neglected. So if bulb is located just above the pile tip, then this portion is going to be neglected. Now if I remove this portion, so what is the base area? You can observe. Now this is going to be the base, and what is the dia over here? dV. And you see there is a resistance. This is the load. There is a resistance on the sides, and there is a resistance at the base. This is QB, and here it is going to be QS. So my dear, now you see QU is equals to QB plus QS, which means FBAB plus FSAS. I'll explain for the clays and you can write for the sands. Say, okay, in clays, QU is equals to FB CNC into AB plus FS alpha C bar into AS. Now keep that in your mind. AB here. Here the AB is area of bulb portion, which means pi by 4 into dB square. So, and what about AS, sir? Pi dl. So along surface of shaft. My dear students, if you observe, I hope you can see the difference over here is the area of the bulb. See, in the case of straight bulb, there pi by 4 d square. Now I am writing pi by 4 d square. When the area is going to be increases, then the ultimate load carrying capacity of under-removed pile is going to be increases. So if bulb is located just above the pile tip, then you have to consider the area of the bulb portion as AB. So now this bulb portion AB is equals to pi by 4 dB square. Pi by 4 dB square. It's not d square, it's going to be dB square. I hope you understood. Now, last point with this I'm going to conclude. If bulb is located shaft, right? If shaft projection is more or if shaft projection below bulb is considerable, if it is going to be considerable, like so if the pile is going to be looks like this, if the pile is going to be looks like this, if the shaft portion is going to be considerable, now observe here clearly. If L is the length of the pile, I am drawing first figure. If L is the length of the pile, now if X is the if X is the length of the bulb, see the dia of the bulb is going to be different. The center, the maximum portion is going to be, this is going to be dB. Now you see, when you apply load, now the resistance will be offered on the sides, and here at the base there is a resistance. This is known as a skin frictional resistance. But there's at the base there is going to be the base resistance. Base resistance QB at the base, okay, and bearing, let's take it as a QB. Now there is a one more resistance over here. If you observe clearly, there is a one more resisting at the bulb side. Whatever this resistance is known as a QEB. See, you know that when there is no shaft or when there is no bulb, this is the portion. Yes, look over here. When there is no bulb, this is the portion. Now, at that condition, Q is equals to QB plus QEB plus QS. What is this QB, sir? CNC into what is this B? Pi by 4 D square. Now you know that D is nothing but dia of shaft. Plus at this point C dash into NC into pi by 4 into dB square minus d square plus QS. QS means alpha into C bar into pi d into L minus X, where C is cohesionate pile tip, C dash is average cohesion yet bulb portion, and C bar is average cohesion along surface area along length of pile, which is going to be L minus X. In the case of uniform deposit, you see C is equals to C dash is equals to C bar. Look, let me repeat this again. Look, at the base, there is a bearing resistance that is known as CNC into pi by 4. Which one now? There is a shaft. See, earlier, in the previous case, if the bulb is located just above the pile tip, the shaft projection below the tip is going to be neglected. So, here the base resistance is going to be due to whom? Pi by 4 d square. Here I wrote it as a d square. And there is a side resistance directly. I can write it as a pi dl, and I can neglect the length of this bulb also because very small. But now if you see, when there is a length of the bulb. Let's take the length of the bulb as x. And in this zone, if you see, whatever this outside portion is going to be having some extra end bearing resistance, right? And that is going to be, see here, QB CNC into pi by 4 d square plus here QEB. What is QEB? The QEB is equals to C dash into NC into pi by 4 into dB square. What is dB square? The dB dia of the bulb minus d square, which means this portion. The outer portions are there or not? The outer portions are this area and this area. They are taking the total area minus shaft area C dash into NC into pi by 4 into d square. And apart from that, in the remaining length, exclusively if you remain the x, if you remove the x, whatever the length is there, L minus x, there is a skin frictional resistance which is known as alpha into C bar. So this is the entire analysis for the shafts, means under removed piles. See, you don't need to worry about this topic much. I have given this. If you want to remember this formulas, fine. Else, you don't need to remember this. Don't worry about that. Yes, it's completed. It's completed. Okay, it's just completed. But one point. See, if an uplift load is applied on under-reamed pile, if an uplift load is going to be applied on under-reamed pile, I'll give you that screenshots also. Just wait. So now, just simply from case B, remove first term and add weight of pile. You see this condition, whatever this is, Look, so here if you apply an upward load, means uplift or tensile load. Now see, so far I have explained for the compressive load, right? This is a compressive load, and in the case of the tensile load, so now when you apply the uplift load, now I'm lifting up. So this is known as a tension pile. There is a resistance offered downward, and on the bulb also resistance will be offered downward on the bulb, and this is nothing but the weight of pile. See, just you see the difference between the previous one and this one. If you observe the difference between the previous one and this one, in the previous one, when you apply load, the resistance is at base. So what is this base term? First term. Now what I do is, I simply remove the first term. In this case, from case B, remove first term and add weight of the pile. That's it. So if I apply the load, now you see this is known as skin frictional resistance. And at this point, there is a QEB. So what is the ultimate load over here is, remove the first term QB here, weight of pile plus QEB plus QS. So the weight of the pile is nothing but they will give you the weight of the pile. So what is our QEB? Weight of pile plus QEB means C dash into NC pi by 4 dV square minus D square plus C bar plus alpha into C bar into pi D into L minus X. So that's about this. If an uplift load is going to be applied, see, might be you think these are too many formulas, but if you observe, I am writing whatever the load and resisting. What is resisting? QS. You know what is resisting? Skin friction is nothing but Fs, alpha into C bar into length. What is a pi D into length? The total is L, remove X. Because in this X portion, we are going to consider whom? QEB. And what is QEB? C dash into NC into pi by 4 into dV square minus D square. So with this, I completed the entire foundations topic, and tomorrow we are going to discuss about the soil exploration and sheet piles. With that, we'll be completing the GATE syllabus. So please have a look once. Well foundations and drilled piers are not for the examination, so you don't need to worry about the well foundations drilled piers. So this is uplift. So the difference you please observe from the case B, remove the first term and you add the third term. That's it. Please, if you want to take a screenshot, you can take. Now I'm going to enable the means. So if you want to go out, you can go out. Means if you want to leave the class, you can leave. So the class has been ended. Now I'll be taking a doubt clearing session up to 2 o'clock. I'll take up to 2 o'clock. Now this chapter is completed. The chapter is completed. So Tomorrow give 1 hour break, sir. Yes, sir. Tomorrow you take full break, Ray. Who is asking you to take one hour break? See, this is downward drag is not due to the negative friction. This is due to upload, means load, type of load is uplift load itself. I can write, means just write for the sake of purpose. Due to uplift load, resisting frictional force acts downward. And due to compressive load, resisting skin friction acts upward. So don't think this downward as a negative skin friction. That's not true. Okay. So, now, I hope you understood these conditions. So fine. See, just take these conditions for the sake as we have been discussed everything. So that's why I took. Now let's start our doubt clearing session, my dear. I am enabling the conditions. Anna, raise your hands. Now we can speak out. First, Mr. Amit. Mr. Amit.
Hello.
Yes, Amit.
Sir, previous gate, page 76.
Previous gate. Hello.
Page number 76. Page number 76, sir.
Yeah, 1 minute. Just tell me.
Question number 19.
What happened, my dear?
Sir, I couldn't.
What happened over here is you see this one, phi is equals to 25 degrees, right? Which
Yes,
is
sir.
less than 28 degrees. What is the type of failure? Local shear failure. And in the case of the local shear failure, see, they have given the NC, NC dash, NQ dash, and N gamma dash. Okay. Understood?
Yes, sir.
Yeah. So for phi, they have given NC, NQ, N gamma. At the same time, you don't take the phi. You have to take phi m, right? What is phi m? Tan phi m is equals to 2/3 of tan phi. And these values are going to be NC dash, NQ dash, N gamma dash, which means I said you in clearly in the class itself, when they mentioned the local shear failure, or if phi is less than 20 degrees, now they have given NC dash, NQ dash, N gamma dash. So which one will you use?
Sir, dash. NC
Yes, that's
dash,
it.
NQ. Okay. Sir,
Yeah.
how do you know that this is a local shear failure?
Yeah, see, you wrote, I wrote that right. Phi less than 28 degrees, no?
Okay, okay. That's why, sir. I did it wrong. Thank you, sir.
Yeah. Next, Sachin, speak out. Okay, Aditya, speak out.
Hello,
Mr. Aditya, tell me.
sir. I have doubt in previous ESC, sir. Page number 79. Thirty-fourth question.
1 minute. Page number
79, sir. And 97, sir. 97, sir.
Which chapter it is?
Page number 97, 34th question, sir. Bearing capacity.
Number, please.
34.
I have explained this question as Aditya yesterday.
Sir, this by drawing tangents we have to do, no, sir?
No. Actually, this is log plot, right? See, it is going to be normal plot QS.
Yes, sir.
Then the graph is going to be. Then the graph is going to be this one. Okay.
Yes, yes, sir.
In this case, we have to draw the initial tangent and final tangent. This is a tangent.
Yes, sir.
But if you go for directly the log scale,
Means settlement also and in bearing capacity also log both.
capacity also, then what you get is directly the values, like when you draw, the curve will be look like this.
Okay, sir.
So in the case of the local shear failure, the curve will be directly looks like this. So then
We can find directly. Yes, sir.
yes.
Yes, sir. This is the doubt, sir. That's it. Thank you, sir.
Okay.
Yes, sir. Thank you, sir.
Yeah. Now, Mr. Pawan, Mr. Bhukia Pawan Kumar, speak out. Mr. Pawan, speak out, please.
Good afternoon, sir.
Good afternoon.
సార్ డౌట్ వచ్చేసి 14 చాప్టర్ సార్ గేట్
Chapter,
14 చాప్టర్ గేట్ సార్
yeah, 1 minute.
3 మార్క్స్ క్వశ్చన్ సార్ ఒకసారి 3 మార్క్స్ క్వశ్చన్ 3 మార్క్స్ క్వశ్చన్ సార్
3 marks question.
3 or 4 మార్క్స్ 1 minute.
What man, what are you talking? Gate, right? 5 marks question you are saying?
ఎస్ సార్ 5 మార్క్స్ క్వశ్చన్స్ 14 చాప్టర్
14 chapter. Please say the page number, please.
1 minute సార్ సార్ పేజ్ నెంబర్ 62 సార్ 61
Page number 61.
ఎస్ సార్ సార్ సెకండ్ వన్ ఒకసారి చెప్పరా సార్ సెకండ్ వన్ క్వశ్చన్
Page number 61.
61 సార్ సెకండ్ క్వశ్చన్
It only, right?
గేట్ 2000 సార్ క్వశ్చన్ పేజ్ నెంబర్ 61 5 మార్క్స్ 2 క్వశ్చన్ సెకండ్ క్వశ్చన్
Marks?
సెకండ్ క్వశ్చన్ సార్
Yeah.
అందులో బి చెప్పండి
What's
సార్
the
ఒకసారి
problem?
బి అర్థం కాలేదు సో అది బి లొకేషన్ ఆఫ్ ది రిజల్టెంట్ లైన్ ఆఫ్ యాక్షన్ ఉంది కదా సార్
No.
అక్కడ డౌట్ వచ్చింది సార్ అది లైక్ ఎట్లా చేయాలి సార్ అది
Resultant, see, you find out, see, I hope I'll draw directly the, see, this is a C soil, right? Means a C0. And moreover, above 5 and 30, below 5 to 30. So K1 is more,
ఎస్ సార్
then Ka2 is going to be less. This is going to be the present distribution, I hope so you get. Okay?
ఎస్ సార్
Yeah. So now,
ఎస్ సార్
take this portion, above portion as F1,
ఎస్ సార్ బిలో
below
F2
portion as F2. This
total
is a
of
total now. Okay.
ఎస్ సార్
So whatever this one is going to be X1, which is a X. This is H by D. Let's take the depth is going to be how much they have given a depth. Na, I'll tell you that. What is this 3, right?
Yes,
This
sir.
is going to be 3 by 2, and whatever this depth is going to be, how much they have mentioned. So I can write x values, x1 value over here. So x1 is equals to, so bottom is going to be 3, 3 plus h by 3, 3 by 3, which is going to be 4 meters. Because this value is going to be h by 3, right?
Yes, sir.
Understood? And
Okay.
x2, you have to do it by means of the trapezoidal centroid. What is the trapezoidal centroid? I have mentioned, right? H
Yes,
by
sir. B,
3
B, B,
to
B
b
plus
plus
2A
2a. So
by
whatever
B plus A
b plus 2a by b plus a.
plus A.
F1 and F2, x1 and x2, x bar is equals to F1 x1 F2 x2 by total force.
F1 plus F2. Yes, sir.
I explained this
Sir.
procedure in the class. You please go through that once.
సార్ ఓకే సార్, కానీ వీటికి ఆన్సర్ లేదు కదా సార్, అంటే ఇక్కడ కీస్ ఇవ్వలేదు కదా సార్, అందుకని అడిగా సార్ ఒకసారి ఆన్సర్ కరెక్టా అని తప్ప అని.
ఆన్సర్ ఇవ్వాలా? ఓకే, ఆన్సర్ కావాలని అడిగింది. 1 minute నుంచి.
అదే సార్, వీటికి ఆన్సర్ కావాలి సార్.
See, this value is going to be 12.48.
Yes, sir.
Sorry, this below value is 12.48.
12 point, F1 is 6 something.
Yes, you got that one only?
No, yes, sir.
So below this value is 12.48 and above is 16 kilopascals.
Yes, sir.
And at the bottom it is like 46.74 kilo.
4. Yes, sir.
And if you solve this h bar, okay, see they have solved directly. The value should be is going to be 1.80 meters.
Yes, sir.
The active force F1 plus F2,
1 plus F2.
it is going to be 112.83 kilonewton per meter. Okay.
Okay, sir.
These are the values. Okay, Tom.
Okay. Okay. సార్ ఇది థర్డ్ క్వశ్చన్ చూడరా సార్ ఒకసారి.
దీంట్లోనేనా?
అవును సార్.
సొల్యూషన్స్ కావాలా?
అవును సార్.
That's factor of safety against lateral sliding. ఇవన్నీ కూడా this will be coming
వేరే చాప్టర్ కదా.
in
అది
means it will be discussed, not now. Okay.
ఓకే సార్.
Yeah.
ఓకే. ఓకే, థ్యాంక్ యూ సార్.
Okay. Ahiti.
Hello. Good afternoon, sir.
Afternoon.
Sir, I have a doubt in 13th chapter, shear strength law, sir.
Shear strength.
Concept, sir, not question.
Tell me.
Sir, during construction of payments, execution of soil appudu U becomes negative annaru, and effective stress is more initially annaru kada, sir.
I did not get you.
During construction of payments, by excavation of soil, pore water pressure becomes negative immediately, then effective stress is more initially annaru kada.
Yes.
Sir, but when excavate soil, total taggutadi kada, sir. So effective stress lo variation undakodu kada.
No, that's not a total stress. It's about the pore water pressure. It's about the water pressure. When you remove the loading, okay, what happens over there is, so the particles tries to reorient. When the particles try to reorient, initially it's a pore water pressure is going to be decreases. See, just simply, Nana, one thing, when you excavate the soil, then according to the nature of the soil, it has some elasticity, right?
Yes.
So when, see, just imagine yourself, you press your foot on a soil mass, heap of a soil mass. You press your heap of soil mass and you remove the foot. When you remove the foot, does the soil is going to be same when you compressed or you try to regain?
Okay.
When it tries to regain, a little bit amount of the dilation is going to be happen or not?
Direction, little bit of
Dilation.
dilation. Okay, okay, yeah.
Yes, whenever the dilation comes into existence, there the pore, see, in simple words, the void space is going to be increases. What is meant by pore water pressure? The pressure exerted by the water in the voids. Yes or no? As
Yes.
as the soil tries to remold, means it's going to be regained, the void space starts to increase. When the void space is going to be increases, the pressure exerted by the water on the solids is going to be less, right?
Yeah.
Yeah, that's it.
Yes, sir.
Pressure decreases, so that effective stress will increase.
Then effective stress will increase.
Effective stress increase immediately.
Okay, okay.
And with
So, but
respect,
with dilation, contact between particles will decrease, right? Then how will effective stress increase?
no. See, in the particular voids I'll draw now. You see. These are the solids, right? Okay. When the dilation occurs,
Yes.
what happens is, see, already some more particles would be there here. Dilation occurs, what happens is these particles will be compressed, and whatever the water here, these particles will come over here, and this particle will move, and this particle, this, see the contact now. Earlier the contact is going to be less. Now due to this water present over here, as the soil gets dilates, the contact between other particles is going to be increases. Understood?
Okay. Yes, sir.
So this is one particle, this is one particle, this is one particle, this is one particle, this is water. When the water is going to place a negative pressure, means tension pressure, then these also going to be water, then these two particles will come closer or not?
Yes, sir.
That is known as increase in effective stress.
So, and the same thing with time, pore water pressure increases
Yeah.
and results in loss of strength. Why does it increase?
Huh?
Why does it increase with time?
When you apply load, Re Baba, you apply load, pore water pressure increase. You remove the load, pore water pressure decrease. Opposite.
But when we apply load, okay, now again due to reorientation, effective stress will also change.
Yes.
So if there is no reorientation, effective stress won't change because with load there won't be any return effective.
When you don't remove the load and when you don't add the load, no change in the effective stress.
So when this, but when we add the load, it will be taken by total stress and pore water pressure equally also. So there won't be change in any effective stress.
Forget about the total stress. Total stress won't change at all. You please the pore water pressure and effective stress. See,
So with load, total stress won't change at all.
Yeah, listen, one thing. If you don't apply any load, there is no change in the effective stress. Okay, point number one clear. Now point number two. When you apply an external load, initially entire will be taken by water. Pore water pressure will increase and effective stress will decrease when you apply the load. Understood or not?
Yes, sir.
That is happening
But
immediately or after a long time?
after long time.
Oi, that's immediately, right?
Okay. Yes.
And over the period of time, as the pore water goes out, excess pressure decreases and effective stress increases. Okay.
Okay.
So in the case of the loading condition, immediately due to development of positive pore water pressure, effective stress is less, strength is less. So we have to study, once you study the structure, immediately you have to check the stability. Why? Because with respect to time, when the water goes out, then what happens is effective stress increases. Understood?
Yes, sir.
But in the case of excavation, means removal of load, when a load is going to be removed, initially positive pore water pressure will increase and effective stress is going to be increases. Understood or not? Or just simply, I'll keep some heavy load on you. If will you feel relaxed or not?
Yes.
The same thing, soil also feel relaxed. Then the effective stress is going to be more, and its strength is going to be more than.
Okay, so that part I understood. But when you put on load, total stress also will increase, no, sir?
Total stress will increase. Fine, I know that. But The total stress, whether you put the total stress remains constant throughout the time, right?
Yeah.
When you
But
give
once we put the load, there will be increase in total stress.
here, you are not coming to the point. Listen to the point clearly. Yes, the total stress increases. Whether you keep the load for 10 years, the total stress is same. But the positive, but the pore water pressure and effective stresses are not going to be same. Okay.
Yes, sir.
So remove the total stress concept from your mind. The total stress increase, but that will be constant.
Okay. Yes. Thank you, sir.
Mr. Pawan Kalyan. Mr. Pawan Kalyan, speak out.
Hello, sir.
Yeah, Pawan, tell me.
Sir, my doubt is regarding previous ESC, sir, bearing capacity chapter. Page number 93, sir.
1 minute. What's the
Second question, sir. Like PDF page number 93, sir.
PDF page number 93 and which question in that?
Second question, sir. Second question.
Number 7 you say?
Second, sir. 2.
2 means this question assertion and reason type?
Yes, sir.
Yeah, what's problem?
Like, what is the correct reason, sir? They have given the reason is not the
Exactly,
correct.
bearing capacity is not applicable to deep foundations. Yes.
Yes, sir.
Yeah, that's true. And shear strength is mobilized on the side of the deep foundation.
Yes, sir.
We are not applying for the deep foundations. In the case of the deep foundations, we neglect the shear resistance.
Yes, sir.
So as we neglect the shear resistance, we don't use. Reason, if I would have given the reason as in the case of shallow foundations, the side resistance of a soil mass is neglected. So that is the reason why we don't use the Terzaghi's equation for the deep foundation. And here, shear strength is going to be mobilized on the sides of the deep foundations. Terzaghi is suitable only for the shallow foundation. And whereas in the case of the deep foundations, shear strength is going to be taken. So
Yes, sir.
two different entities, two different statements, both are true. Understood?
Yes, sir. Yes, sir.
Yeah. And there is no interrelation between these two.
Like in deep
Whereas
foundation,
in the-
due to the development of shear strength,
the
only we are
shallow
not considering.
foundations also, in the case of the shallow foundations also, side resistance would be there, but Terzaghi is going to be neglected. So he has done his analysis, but see, shear strength is mobilized both on shallow and deep, but in Terzaghi, he neglected for the shallow foundations. And moreover, Terzaghi's bearing capacity is not applied for the deep foundations because he neglected that.
Okay, sir. Okay, sir.
See, these are two different statements which are not going to be interrelated.
Okay, sir. And question number 7, sir.
In this chapter,
Yes, sir.
one minute. Where is this? Question number?
7, sir.
Tell me what's in the question number 7. What's your problem?
Like local shear failure, it is suitable for medium compressible soils, and failure is not sudden. Like from 1 and 2, which should we take?
See. The point here is, see, from the given options actually. You look over the given options. These just you have to go with the elimination procedure here. You see,
Yes, sir.
failure. Local shear failure is well defined, but the failure is not going to be sudden. Yes or no?
Yes, sir.
General shear failure is sudden failure, but local shear failure is a gradual failure.
Yes, sir.
So from this, we can remove the option 1. If you remove the option 1, remove A, B, D, then it's going to be 2 and 3. And the same question, if I give you punching shear also, the answer is going to be 2 and 3. I hope you understood here. Understood? See, the examiner has given in this question in such a way that He wants to compare general shear failure and local shear failure. Compared to GSF, LSF is going to be compressible. Compared to general shear failure, LSF has a high settlements. Yes or no?
Yes, sir. Yes, sir.
This meaning is, in this question, the meaning itself is a comparison of general shear failure with the local shear failure. And the tip is, when you came across this type of questions, what you do is, you just simply eliminate the option.
Okay, sir.
If you eliminate the option, the answer is going to be 2 and 3.
Okay, sir.
Okay.
And last question, sir. 19th question, sir. Same chapter.
Same chapter.
19, sir.
So yeah.
So the reason would be liquefaction, no, sir?
No. See, a wooden bridge in Assam failed was observed to have arched up in the middle after the earthquake. Arched up in the middle. See, this is arched up in the middle means what is the meaning of this one? This is a wooden bridge. And whatever the soil mass over here is a bridge. Whatever the soil mass over here. See, the meaning of liquefaction is a failure of the soil mass, right?
Yes, sir.
Yes, a wooden bridge in Assam field was observed to have arched up in the middle after the earthquake. The right abutment settles 40 mm and left abutment settles by 30 centimeters. See, which means one settled more, other settled less. Which means due to that, whatever the lateral earth pressure is going to be present, are there or not?
Yes, sir. Yes, sir.
Lateral earth pressure only, the walls are going to be settled. During the earthquake, the most probable cause of failure. Shear failure of soil below the abutments. Keep that in your mind. If there is a liquefaction, entire structure would have been fallen down.
Okay.
Entire structure would have been fallen down. But they have said that it is going to be arched up in the middle of the earthquake. The arching is going to happen only at the middle. Only at the middle, not the full structure has been fallen down. So keep that in your mind. It's not going to be liquefaction. And settlements below the abutments. What is the settlement over here? 40 centimeters and 30 centimeters. I gave you the reliable settlements. Yes or no?
Yes, sir. Yes, sir.
Yeah, this settlements is not out of the range. So this is not going to be happen. Shear failure of soil below the abutments. See, if there is a shear failure of the soil mass below the abutments, then you can see the rotation and you can see the heaving. There is no heaving. They did not mention anything regarding to the soil mass failure here. And now the failure of abutments due to dynamic earth pressure behind the abutments. Whatever the earth pressure present over here, the earth pressure makes sure due to the liquefaction, the wall is going to be most away from the backfill and this soil will exert a pressure. That's due to dynamic pressure. Now,
Okay, sir.
okay.
Okay, sir.